Hello, good morning, madam. Am I audible?
हाँ प्रवीण sir,
हाँ, madam.
can you see the welcome slide?
It is getting displayed now, yet it is not visible. Yes, now it is visible, madam.
Okay, thank you.
Tejas,
Pages.
Tejas, co-host करना मला आणि गो लाईव्ह करून टाक आताच.
Yes sir, yes sir.
हा, कारण की लिंक शेअर करायला लागेल आपल्याला युट्यूबची.
Go live केलंय. Tejas has done go live. Okay.
ओके, तेजस प्लीज शेअर द लिंक.
Share.
युट्यूबची लिंक पाठवली हरीश सरांना.
Sir, YouTube link you are telling sir.
हा, येस येस, मला पण शेअर कर आणि युट्यूब लिंक.
YouTube link प्रवीण sir.
त्यांनी पण दिलं झूम लिंक पाठवा 14 फेब्रुवारी.
ठीक आहे, युट्यूब लिंक भेटली, मला फक्त को होस्ट करशील.
हाँ yes sir.
Tejas, am I audible?
Yes, sir.
Okay, thank you, ma'am. Thank you. Dr. Anwar Sheikh has joined the meeting, okay? Just for the
Yes.
information. Everyone.
Yes, yes.
Good morning, Dr. Anwar. Dr. Anwar, good morning. Good morning, sir.
Praveen, sir.
Yes, madam.
That this YouTube live streaming audio is proper, na?
Yes, yes, yes.
Okay, thank you.
Ma'am, please ask Tejas to allow everyone inside, okay? Because there are people who are waiting, and because I'm the host, I'm able to allow them in.
Yes, yes, yes.
And Dr. Anwar ना co-host बनवलाय का तेजस? त्यांचा कॉल आला होता पण आवाज नाही ऐकायला आला.
Okay, we are doing. Dr. Anwar has been made co-host.
Hello, am I audible?
Yes, sir, you are audible, sir.
Okay,
Okay, done, sir.
thanks.
Good morning, Dr. Anwar, sir.
Very good morning, sir.
Glad to see you online.
Yeah, same to
Thank you
you.
so much for accepting our invitation.
Thanks for inviting me and giving an opportunity.
So we'll start in about 2 minutes, sir. Okay.
Yeah, definitely.
Good morning and hearty welcome to dignitaries, delegates, and faculty members. Principal Dr. Rakesh Somani, sir, and resource person Dr. Anwar Sheikh, and all the delegates. We are delighted to continue this insightful journey of 2 days e-FDP entitled Pedagogical Tools and Approaches Engaging Pharmacy Students in Chemistry Classroom. Organized by Department of Pharmaceutical Chemistry, D.Y. Patil deemed to be University School of Pharmacy in collaboration with APTI Maharashtra State Branch. Let's build further on the knowledge shared yesterday and make today's session equally engaging and enriching. Before beginning with the session, I would request delegates to post questions, if any, in YouTube chat box in time, and please do not wait till the last moment. Also, a gentle reminder about quiz which will be conducted after the event and submission of feedback form. Detailed instructions will be shared by Coordinator Dr. Harish Kandaikar after the sessions. To give a great start to today's event, we have with us a remarkable personality, Dr. Anwar Sheikh. Dr. Anwar is a distinguished academician, author, competitive exam counselor, and teacher trainer specializing in animation tools. He currently serves as professor and HOD of Pharmaceutical Chemistry Department at Allana College of Pharmacy, Pune. His research focuses on computer-aided drug design and synthetic chemistry. Sir has guided 40 MPharm students and is currently supervising 6 PhD scholars with 2 PhD degrees already awarded. His contributions include 35 international research articles, 4 books, and 1 Indian patent. Sir has been awarded with Best Research Publication Award for his work on computer-aided drug design and has delivered more than 750 talks as resource person at various institutions in India, including UGC Malviya Mission, and trained more than 25,000 staff members for ICT tools in teaching. Sir qualified GATE and NIPER in 2001 with All India rank 101 and MPSC examination in Maharashtra State 4th rank for Assistant Commissioner FDA in 2012. Sir has developed mobile application named Pharma Career, which is downloaded by more than 1 lakh students and staff members in India and abroad. He is also developing virtual lab for pharmaceutical sciences. Dr. Anwar is actively involved in creating scientific animation since 1997. He has started a YouTube channel with a mission to provide free education to anyone, anywhere. During lockdown, Sir has conducted free webinars on his YouTube channel on various topics related to online teaching tools and research. His YouTube video channel is followed by more than 1 million viewers across the globe till date. We are indeed honored to have you with us, sir, today. I extend very warm welcome to you and invite you to deliver the address. Thank you.
Thank you very much, madam. Let me share the screen.
Yes, sir.
Hope my screen is visible.
It is
Yes, sir, it is
visible,
visible.
sir.
And audio is okay?
Yes, yes, audio is fine.
Okay, good. I shall start now.
Yes, sir.
So I'm starting this session with the name of God Almighty, the most merciful and the kind for us. I'm always thankful to the God Almighty first, because the God has gifted me some skills. Just I'm percolating to the people. I got a good friends, good parents, and all the community teachers. So I'm thankful for the God for this gift. I'm thankful for the DY Patil University, the trustees and the management, as well as the School of Pharmacy for hosting such a wonderful FDP, 2 days FDP, which is subject specific and which is focusing on a specific topic, that is engaging students in a chemistry classroom. I'm thankful to Dr. Somani sir, Rakesh Somani sir, Harish sir, Monita Gide madam for inviting me and considering me for this session, and all the delegates who are present today and attending this session. So I will be focusing more on pedagogical tools and engaging pharmacy students in chemistry classes. So when the terms comes chemistry classes and engaging students specifically in the chemistry classes, so there are some observations, my personal experiences are there, because I'm teaching analytical chemistry, spectroscopy, organic chemistry, out taught medicinal chemistry. Every classes I have faced biochemistry of this chemistry background from my last 15 years experience, and not confined to a specific region. I taught in Gujarat also. I taught in Maharashtra also, in other state also, in various colleges. So from my experience that uh, as we are focusing on the chemistry teaching, so the chemistry teachers are having specific challenges regarding the subject. Whenever I start this chemistry subject in my first year classes, I generally take the feedback from the students that uh, do you like this subject, or are you afraid of this subject, and what is the problem with this subject you are facing major. So I got a very good answer from one of the student, and he told me that sir, chemistry is a volatile subject. So this is one of the challenge for the chemistry teacher of teaching this subject. Chemistry is a volatile subject. Why it is a volatile subject? That they are saying that we don't remember the concept, we hear and then we forget all the things what has been taught in the subject of the chemistry. So they consider chemistry is one of the volatile subject. There are a lot of hypotheses in this subject. This is another challenge for the chemistry, because no one has seen the structure of the atom by their naked eye. These are all the considerations, all the theories, all the hypotheses. We have to imagine the chemistry, that there is a nucleus, electrons are orbits are there, then electrons are circulating in the orbit. All that, these are the hypotheses. No one has seen the s orbital, no one has seen the p orbital, how the hybridization is taking place, orbital mixing is taking place. So we have to imagine, and we are expecting the students are should also imagine in the same way as written in the book. So that is another challenge, to bring that hypothesis in such a way, or to deliver that hypothesis which is we have not even seen, in such a way that it becomes very easy and understandable to the student with respect regard to this chemistry subject. So one day the student was telling, sir, today, and there are also a lot of anomalies are there. One day the student says, sir, yesterday you told that electron withdrawing groups are meta directors, and today it is written in the book that halogens are electron withdrawing, but they are orthopara directors. So there are some anomalies are there, which are we have to explain with some evidences. But the things, it is not like a straight chemistry. So there are certain anomalies in the subject also. So these are also some of the challenges for the chemistry teacher to explain them in a better way. Third and the most important thing that we are now coming across, that is a challenge for the chemistry teacher as well as other teachers also, is that background of the students of the new generation. Now you might be observing, this is might be also your personal experiences, that how the students are involved too much in you can say the social media, audio visuals and all, and they like those things. They are getting the information from all these sources, but it is well said that it is a great truth of the age that information is not a knowledge. Information is a collection of the data. It is always present in the form of a data, but experiencing that data, experiencing that information, following that information, using this information and applying as a skill, that becomes a knowledge. So that is the difference. Today, the students want entertainment in every field, every subject, everywhere. They are most likely the entertainment. Best example that I will quote, that you say the students that tomorrow I am having the extra class of organic chemistry or medicinal chemistry, and you have to come at 9 o'clock. You observe that how many students will be coming for attending the classes, and the same announcement you convert like that. Tomorrow we are having a DJ party at 8 o'clock or 9 o'clock, and there will be the dance and the DJ party. They will come at 7 o'clock. So that is the truth. So they need entertainment everywhere, and here sincerity is needed to learn this chemistry subject. So both the things are conflicting. So that becomes a challenge for the chemistry teacher, that background of the students of the new generation. And another important part is incorporating modern ICT tools and pedagogies in our lecture delivery. How much we are interested to learn these ICT tools, and how many of you are actually incorporating the ICT tools in our teaching learning process. How much we are making interactive this subject using these ICT tools. So it is a challenge also, and that's why I written challenge as well as opportunity for a chemistry teacher. So this is an opportunity also to make the subject more interesting using these ICT tools. One of the ICT tools is animation. So what is the importance of this ICT tool in today's era? You might be observing that the traditional versus the modern classroom. The classroom has been shifted as the time we were sitting in the classrooms, blackboard and the chalk. And now the kids were sitting in with their own personal computers and smart screen in the classroom. So now the technique of teaching has been changed with the help of these ICT tools. So there is a need of adopting these tools. There is a small video that is the impact of technology on our daily life. Let me know the audio is.
Technology is the ubiquitous sign of human imagination. With
Video is background audio, you can see here.
its ability to aid and inspire. From the
Yes, sir,
point
it's
where you
audible.
rise, it keeps you seamlessly wired and ready to take on your day. However you travel, it is now an extension of whatever you choose to give your attention to. Whether it's continuing that ebook you were reading or getting a head start on your work. Check up on your home or zone out to your online series. Never miss a beat. Whatever your work requires, there is always a need for synchronicity between all your platforms in the search for success. Just like finding harmony, cross-platform synchronization between all your different peers and devices allow for greater satisfaction in a world without borders or limits to your imagination. Helping you empower and secure not only your physical valuables, but securing your digital assets, whether it's on your hardware or in the cloud, as well as for your company network or personal use. Have peace.
Just a video of ICT in our daily life, impact of ICT. And someone is asking that really the ICT is important for education. So we learned during the COVID period. Before COVID, we were having the board at the school that mobile not allowed in the school, use the mobile at home and all the things. There were actual practicals and theories. But during COVID, we observed that everything was shut down. And we were totally relied on these ICT tools. Before that, we had never used these ICT tools. Zoom, Webex, Google Meet, then GoToMeeting, Microsoft Teams, we have never heard and taken the. Now we can easily take the online meeting. Now this webinar is going on online way. I'm sitting at Pune and various people, they are sitting at their own places and everyone is gathered together and they are getting this knowledge and information. So it is possible through these ICT tools. I was wondering about that. This COVID has been would have been taken place in 1990s or 20, where there was even the internet 2G or 1G was there, and even this Webex and Zoom, everything was not available. What we would have done? for those 2 years. So it is you can say the boon of this ICT that we continued our 2 years of this COVID era with the help of these ICT tools. This is the importance of ICT that we used in this COVID era. So what is exact meaning of the ICT? Information and communication technology. It is what? It is communicate, create, disseminate, store, and manage what? Information, which is in the form of data. The information which is in the form of data, or you can say images, diagrams, paragraphs, and all. And use ICT tools, use technology. The technology is including electronic devices, maybe the web resources, maybe the software tools, or it may be internet interactive tools. Combining these two things, and we are getting whatever, say for example, in this there is a you can say diagram of the heart, theoretical one. If the zoom is working in your screen also, zoom in is also working in your screen.
Yes, sir, it is working.
So say for example, this is the thing which is written in the anatomy book. All the written concept and images are there, and with the help of this software tool, if the same thing we can convert into this one. So this is the use of, you can say, the information and communication technology. So we are incorporating this information, and we are using the ICT tools, and we combining them, and we are getting something which is more interacting and more interesting. But what is the purpose of this? What is the outcome of this? To create interest. Why we are doing this? To create the interest among the students of our subject, to simplify the very complicated concept, to increase or to improve the understanding, and to make the things more realistic. So these are the more, you can say, the 4 objectives using these ICT tools. Now, ICT tools and learning process involves effective learning. Effective learning is possible by 5 senses, as we know. That is your eye, hearing, taste, touch, and smell. And one of the study, according to a psychological study that is published in a journal, it was clearly mentioned that a human can grasp 80% from audio visuals, 80%, and remaining from 20% from the others. So that is the impact of these 5 senses of the ICT. I will prove it. I will just ask few questions of you. You have to unmute or immediately type in the chat box, so that the session will be more interactive. Are all of you ready? Yes.
Yes.
So you can unmute. Please unmute all, and I will ask the question to you, or you can immediately type in the. So I will show you one small clip of a movie. So just listen it. Can you listen the voice?
कितने आदमी थे? सरदार, 2 आदमी थे। 2 आदमी।
Okay, so my question is that what is the name of this character of this movie? Can anybody reply? Yeah, Dr. Praveen Naik, excellent. Sholek, very good. What is the name of this character? Someone immediately type in the chat box or unmute and tell. What is the name of the character in this movie? Okay, great. So you are knowing something about it. Others please also reply in the chat box. something about this movie. Okay, I will show you the another image. So can you tell me the name of this movie? Yes. Please write in the chat box. Okay. Anyone else? Okay. I will show you the third image. Tell me the name of the character you can see. So please write in the chat box immediately. Write in the chat box. Okay. I think Praveen sir is the only active participant here. Yeah. Archana madam, thank you. So this is something I told you, that is the correct answer. I will show you the fourth image. And my question is that drive an expression for the Newton's law of gravitation. So you have to completely write this Newton's law of gravitation. So what is happening here? We are there are some thing that you are thinking. You have learned it in the class of 11th or 12th, but you are not able to explain it properly here. But because you forget it. So the left hand side is very clear to you, lot of things, but right hand side you are having the problem. Why? Because in the left hand side, the information and communication tools, that is audio and visuals, were there. And right hand side, you learned it and then you forget it. So that is well said, that I hear and I forget, I see and I believe and I remember, and I do and I understand. So the middle line, that is I see and I believe and I remember, that is working with the help of animation. So if you incorporate animation in our teaching learning, especially for the chemistry subject, then definitely the student will be able to remember the things for a longer period of time. So it is having some scientific background, that how audio visuals is importance in you can say increasing the memory. There are a lot of books, anatomy and physiology books, where this part is written, that is known as a visual memory. So visual memory, it is some part of our brain, sensory motor cortex, posterior parietal association cortex, dorsolateral preferential cortex, where the information what we see and we hear, it collects and stores for a longer period of time. So that is known as a visual memory. That's why audio video tools are important here. Nowadays, we are having most of us are experiencing such a situation in the post-lunch sessions of our organic and chemistry classes. But if you want to convert this image to this one, definitely you have to use some interactive tools so that our students get completely engaged throughout our lecture. So the teacher's dilemma is that since the technology has made such a tremendous progress, can this help me in my teaching learning, and how I can use these tools? Okay, so it is not like that we are not at all using ICT tools. We are using the PowerPoint presentation, which is one of the simplest form of ICT tools. You are accessing the emails and blogs, downloading the videos and showing to the students, downloading study materials. These are the things we are using. These tools we are using. Sometimes some software we are using in our teaching. But lot of tools other are available. We are using very less part of the ICT tools which are available. One of the tool explaining some basic concept and mechanism in the form of animation. It is one of the tool of the ICT tools. So what is an animation? So animation in the simple language, it is a creation of creation of the illusion of the moments using a series of the still images. Means what? Some whatever the animations you are seeing here, these are actually the still images, not moving images. Various frames are there, and these frames are collected and they're running so that it looks like an animation. So this is the simplest definition of animation. What are the potential advantages of animation? So with the as compared to the static graphic, the animated graphics are more informative, more closer to the real characteristic of the subject matter, more explicit, more explanatory, and more clearer. Why it is so? See here one example that a teacher in a chemistry class regularly is teaching a Bohr's atomic model.
Bohr's model consists of a small nucleus, positively charged, surrounded by negative electrons moving around the nucleus in orbits. Bohr found that an electron located away from the nucleus has more energy, and the electron which is closer to nucleus has less energy.
So this is how that, yeah, and the same concept is converted into this animated form.
Bohr's model.
Based on his observation, Rutherford proposed the nuclear model of an atom. The positive charge is concentrated in the center of the atom, which is called the nucleus. The electrons revolve around the nucleus in circular paths called orbits.
So
The nucleus is
which one is looking more explanatory? The earlier one, the only the on PowerPoint, the you can say the paragraph was there and the teacher was explaining, or this one there along with explanation simultaneously animation is going on. So which one will be more interesting for the student? What you think? The first one or this one, where animation is incorporated? Yes.
With animation, sir.
Yeah. Thank you, Dam. So that's why there is a need of the animation. What are, as we started with the animation, so some briefly I will tell you what are the types of animation. Earlier there was the hand-drawn animation where the various you can say advanced tools were not available. Then came the stop motion animation. You can see that moving image, and now we are using these computer-based animations, which is more easy to learn, and you can say the less time consuming, and it gives the results which is more realistic also, and less efforts are needed here. That is the modern type, that is the computer based animations. So here we are using certain softwares to make the animation. Now what are the methods of animation, how the animations are made? The first and the very simple method, that is known as the animating the still image. There are certain softwares are there, like pencil is there, then you can say the 2D paint is there. Here by using those softwares, any image you can convert into a small animation, like the microscope you are seeing, that is made with the help of it, you can say still image. Okay, it was not motion, but the motion was given with the help of that software. So that is one of the things, like you are having any machine diagram, or you are having anatomy images, and you want to move them, you want to come bring into the motion. So that is one of the methods. Still the ready-made available still images. Second, making flash movies, 2D animations. There small softwares are needed, 2D animations, which are not we can say very difficult to learn. Then third is animation in the PowerPoint. So whatever the tablet rotatory machine you can see here, this is made on you can say PowerPoint. So I think you are not believing that it is made whether it is possible to make such animation in PowerPoint. Okay, well, the same PowerPoint we are using for our lecture delivery, and now it is possible that it is made. So I will show you how it is made. That much time I'm not having, but I will show that PowerPoint PPT where this was made. Just Yeah, this one. So I will show you the same animation that was created on the PowerPoint. Yeah, this one. So can you see this PowerPoint presentation? So it is a PowerPoint, it is a PPT, and I will just run it. And I will show you in this animation how the animations are given. So you can see all these animations are given. Can you see these dash arrows and all this? So these are the animation paths which are given, and this is the animation pen I will show you, left hand side. These are all the animation pens which I have given to this to create such type of the animation. So it is a PowerPoint actually, and I will run it. And the same thing that is incorporated in my this PPT. So this was made from a PowerPoint. So it is a PowerPoint tool. You can say we can create such type of the animation using the PowerPoints. Making 3D animations. Making 3D animation is a little bit time consuming, and here you have to learn some softwares. But for teachers, PowerPoint animations is the best one. You can use them. What are the basic knowledge we should know to make the animation? We should be familiar with working on the computers. The concept to be animated must be very clear that what we are making. You must be having some drawing hand and logic, but by using already you can say copyright free images you can create, which is available on the copyright free websites are there. Then video formats and images, we should know how to remove the background of the image, and most of the softwares are user friendly. But most important is your passion and your interest, because learning this or creating animation in a one shot you can not do, but you have to repeat again and again. Okay, so you can say like this animation what I have shown to you. It is a GIF image. Okay, so how I prepared this image I will show you. So first I collected the various frames of this. You can say these are all the various frames, and with the help of this online software tool, I will show you. Online image editor, free online image editor. Okay, so here there is on if you go there is a GIF maker. This is a free word free is there, so not to pay anything. So I'm just clicking here, and before that I have collected or you can say using our you can say paint. I have made little bit changes in these images. Okay, these are the various frames. So I will show you how I created it. So once I clicked on this GIF maker on this website, will ask you to upload your frames. So whatever frames that I have collected, I will upload here. So I'm taking this first image. I just selected it and just clicking on this plus open button. So that image is and just click on this. After that, click on this upload button. So that my first image is added here. Then I will add another image. I will just add 3 to 4 images. Image number 2, upload. Image number 3, upload. Image number 4, then upload. Image number 5, upload. Okay, so I just uploaded 5 images, and here is the button that create animation. Can you see the animation is created using the images? Is the animation is also working on your screen?
It is working, sir.
So using that 5 images, I have created this animation in front of you only right now.
Yes.
I can download whatever I created from this download button, and I will show the downloaded file. So this is my download file. It came here. And this is, I'm running the download file. So just now I have created it using that online free tool. But the background there is that you must be having this type of the images. Only one image I got from the book, and I little bit changed those images using the paint software. Okay, so you might be observing certain changes are there in every image. So using all those images and running them with the help of that software, you can create such type of the image. Okay. Then requirement may for the making animation like that, you must be having a PC with a very good speed processor, i7, or you can say i5 is okay. 4 to 8 GB of the RAM, 16 GB is excellent. PowerPoint, that is 2016 minimum. Adobe Flash, Pencil, Krita, Open, these are the free to the animation softwares. If you start those softwares, within few days, you will be able to create the animation. Then you must be having a drawing table tablet like this one. If you want to draw something and then convert into the animation, that is a digital drawing tablet. And certain books are there for the animation. And if you want to add our background voice, then you must be having the, you can say, microphone. Now I will show you some animation of chemistry reactions, which can be prepared with the help of using PowerPoint. I have prepared, you can say, some reaction mechanisms. So you can animate the reaction mechanism with the help of PowerPoint. So here is one of the animation that for explaining the retrosynthesis. I will show you the video first, and then I will show you the background of that one, how it is created in PowerPoint. Retrosynthesis of propanolamine. I will show the PowerPoint of this animation. So this is the retrosynthesis, a synthetic approach that we have prepared. So how this disconnection is taking place. So that is a retrosynthesis, how you can use. So when the things are happening, how the molecules bonds are getting break, how the electrons are shifting, moving from one place to another place, why, what is the meaning of that arrow we are drawing, then definitely the reaction mechanism becomes very, very easy. So this drawing this reaction mechanism with the help of these PowerPoint tools, here it is in a 1 hour session, it is very difficult to complete. Only I can give the demos, but I'm having that complete 1 day sessions where I teach how to create creating animations of the reaction mechanisms, so that everything becomes very, very easy for the students. Now this is how in laboratory practicals you can create the animation. This is prepared on the PowerPoint like this one. A drop is coming. Now it is synthesis of paracetamol. So we have taken the phenol, then we are adding the phenol here. So we have that phenol, and then we are adding the nitrating mixture. So after adding the nitrating mixture, what reaction is actually going on? So that is also displayed here. So here there's a you can say electrophilic substitution reaction. So how the electrophile is substituted. Below the reaction will also be going on simultaneously. Also how the nitrophenol is formed. Orthonitrophenol, like that one. So there is another way how you can prepare the animation. The reaction, you can see, prepare the reactions of organic chemistry, synthesis. And these are all prepared in the PowerPoint. Okay, I will show you the background of this. So this is the interactive, I can say, that as the dissolution media, adjust the temperature. By clicking the button, the things are happening. You can say withdraw the sample, like this one. Now here the analytical part, the instrument, if the student is placing this button, drop the sample is dropped. Then open the door. So the door of the instrument is open. Place the cuvette is placed here. Then close the door is closed. Then click the run button. So spectra is running here. So in the same way, the experiment you can create with the help of the PowerPoint. There are some educational video tools are there, like Teacher Tools, Khan Academy, and IT, where you can get a lot of already prepared animations are there. And yeah, you can start your own YouTube channel where you can upload all of these your animations, animated lectures, so that it will be a repository for you for your appraisals also. Use of the ICT tools, effective use of the ICT tools, how you are using it, and what is the impact of these tools, and how the what are the comments. So that will be helpful for your accreditation also. These are some web resources of the animation of the basic sciences, medical sciences, physical, chemical, then you can say medical science video animations. I will share this slide to the organizer. Then interactive simulation for science, pharmacology, life sciences. So here on this website, the ready-made animations are available. You can just download them and you can use for your chemistry classes. Now here are some software tools for animations, like MS Office. A lot of the animation tools are available in our PowerPoint. You can create a lot of animations with the help of them. Then Premiere is there, Maya tools is there. These are for the, you can say 3D animations. Blender is there, so that you can, here the much learning is needed here. Okay, so that is how we can create animations. But the thing is that the search of a teacher should be like few lines which are given by the poet that मंजिल से आगे बढ़कर मंजिल तलाश कर, मिल जाए तुझको दरिया तो समंदर तलाश कर, और हर शीशा टूट जाता है पत्थर की चोट से, एंड पत्थर भी तोड़ दे वो शीशा तलाश कर. That should be the search of a teacher, of and you can say your enthusiasm for learning of these IC tools must be there, because it is well said by Dr. APJ Abdul Kalam that all of us do not have the equal talent, but all of us have an equal opportunity to develop our talents. So some questions at the end.
Yes, sir.
Yeah, because the thing is that if some leader is asking who wants to change, there are three images I would like to tell you. So everyone hand is open. Now again the change, next time the question is changed, who want to change? So that was the image I obtained. And third thing, who want to lead the change? So because it was well said by Charles Darwin that it is not the strongest of the species that survive, nor the most intelligent that survive. It is one that is most adaptable to the change. Because the thing is that you can see this image that in 2009, this pilot and this photographer and the pilot of this helicopter, they were charging very high salary for taking overshoot. That was very risky because no option was available at that time in 2000. So they were charging a very high amount for such a overshooting, which was very risky. Now they lost their job because the something introduced in 2019. What you can say? What is introduced? That is a drone camera. After introduction of this, nobody is asking them for a overshooting because we are having this better option in a 4K. You can take the image in where when there is an incident, there is a fire, there is a floods, then this drone is reaching there and taking the images and has the very good quality videos. So the sentence is that in just 10 years, cameraman and the pilot both lost their job. So the motto of this that upgrade yourself. That is very, very important. So thank you.
Thank you, Dr. Anwar.
Yeah, some questions are there.
Yes, sir. Yes, sir. Let me convey to you that it was an extremely interesting and engaging session. I mean, very impressive, real life, relatable examples from movies, technical background, everything you have covered, sir. Also, you demonstrated how we can make the animations. So, I mean, we were so hooked up to your presentation. So, very rightly, you said that use of ICT tools can lead to effective learning, and I'm very sure that faculty members must be feeling extremely inspired to make use of all this. Sir, there is one question, and it is, are there any ICT tools for analytical chemistry?
For analytical chemistry, you can say what exactly you want to develop in the ICT with the help of that one. Say, for example, if you want to create the titration. So I will say that lot of the tools are there, they are paid one, but the very free tool is this, you can say our PowerPoint. I will show you one analytical animation which I created with the help of PowerPoint. A lot of 2D animation softwares are there. like pencil is there, Krita is there. That software you can use to create your animation.
Okay, thank you so much, sir.
I will show the video which was created with the help of PowerPoint. And it is a with the help of PowerPoint only, and an analysis or qualitative analysis.
In the last 12 months,
Solution is one which contains gram. We are getting a 0.1 normal solution of gram sodium hydroxide.
So this is made with the help of PowerPoint only.
Step 2. Dissolve previously weighed sodium hydroxide in sufficient distilled water. Step 3. Transfer the sodium hydroxide solution from the beaker into a 500 ml volumetric flask. Rinse the beaker with little distilled water and transfer to the volumetric flask.
So this was made with the PowerPoint only. So that tool you can use.
Okay, sir. Thank you. Thank you very much for demonstrating solving the query with so much patience. Apart from this, also our faculty members are there in Zoom meeting, and I'm sure you will have some questions. This is a good opportunity to interact with such a resourceful person like Dr. Anwar Sheikh. Any questions, please?
Actually, time is not much here today, so that I cannot actually give the demonstration on one chemistry reaction, one analytical, you can say, reaction, your
Yes, sir.
experiment, how to create the animation. So I'm having the complete one-day sessions for the complete training,
Yes,
so
sir,
that
absolutely. We
I
will.
can cover all the things
Yes,
in a
sir.
deep way. And all these delegates are making one animation in the training session. So at the end of the evening, everyone is going with one animation.
Okay, that's
Yeah.
great to know that, sir. We'll also take up some such opportunity in near future. Thank you, sir. Sir, will you please stop sharing the screen, sir? I would like to share the certificate here. So as token of our respect and gratitude towards Dr. Anwar Sheikh, sir, we present you with this certificate for being resource person for the event.
Thank you, madam.
Extremely thankful for your extremely interesting, engaging, intriguing, insightful session. Thank you, sir.
Thank you, madam.
Slide.
And Dr. Bijo has joined. Dr. Bijo?
I can
Good
hear.
morning, sir.
Yes, morning.
Yeah. Please, sir, you can please come online if you can.
Yes,
Start with the video. Thank you so much.
Yes.
Dr. Harish, is this slide of like Dr. Bijo Matthew is visible?
No, ma'am.
Share.
Yeah, it is visible now.
Full screen.
Yeah, thank you. Yes, let's move forward. We have another significant personality as our next resource person, Dr. Bijo Matthew. Dr. Matthew is professor of pharmaceutical chemistry department at the Amrita School of Pharmacy, Amrita Vishwa Vidyapeetham, Kochi. Dr. Bijo has obtained his MPharm in pharmaceutical chemistry from the Tamil Nadu Dr. MGR Medical University and PhD from Jawaharlal Nehru Technological University, Hyderabad. Sir's primary focus areas are drug discovery of neurodegenerative disorders, cancer, and molecular modeling, along with design of enzyme inhibitors. Sir has received the top 2% scientist category from the world's Stanford list in 2020 and 2024. Sir has published 245 papers with H-index 47 number of citations in Google Scholar 6806, H-index 43 and number of citations 5701 in Scopus, cumulative impact factor 890 in October 2024. With 16 years of teaching and research experience, Dr. Matthew authored one book, one edited book, 7 book chapters, and 37 invited talks at national and international levels. Dr. B. Matthew serves as his chief executive guest editor of journals Molecules, Current Topics in Medicinal Chemistry, and Current Drug Targets. Sir serves on the editorial board of journals Brain Sciences, Results in Chemistry and Combinatorial Chemistry, and High Throughput Screening. Sir has received Amrit Vishwa Vidyapeetham Chancellor's Publication and Chancellor's Excellence Awards in 2021 and 2024. He received 3 patents from the Korean and 2 German intellectual property offices. So we are indeed honored by your presence, sir, and I welcome you and invite you to deliver the address.
Thank you,
Thank
madam.
you.
Thank you. Can you share my slides? Can you visible?
Yes, just a moment, sir.
Is it visible or not? Now?
Your desktop is visible, sir.
Yeah.
The
Slide is
slides are
visible.
not visible. Slides are not visible. Desktop is visible.
But I shared my slides. Now?
Yeah.
Yes,
Visible.
sir.
Visible.
Yes. Yes, visible.
Visible.
It's not moving. 1 minute. Can you see?
Yes.
You can see, sir. Currently, the content slide is displayed. It was
Yes, yes,
displayed.
yes. Okay.
Yes,
So
sir.
I think so NMR spectroscopy. So as you know that because all we are coming from the chemistry background, this is one of the most sensitive technique which is widely used for the structural elucidation of an organic compound. Okay, so today I will present it because I don't want to give a detailed principle behind in that. So I will show some slides which exclusively how the spectroscopy will be useful for the structural elucidation. Okay, so moving to the content. So before going for the NMR spectroscopy, I should tell some common terms of NMR. Okay, something like the basic principle, the chemical shift,
Dr.
de-shielding and
Bijo,
shielding. Yes, yes.
I'm so sorry to disturb you. Can
No.
you please put it in the PowerPoint mode? Because we are just seeing a very small screen of contents.
Now?
Now it is a larger screen. If you can just put it in PowerPoint mode.
PowerPoint mode only I just made.
Okay, but this is a lot better than the earlier point. Yeah, you can please continue, sir.
Yes. So these are the common things we should know about that. What's first one is the chemical shift, de-shielding and shielding. What is meant by rule of multiplicity? Then how we can show the anatomy of a HNMR spectrum, and by the use of molecular formula and the HNMR spectrum, how we will elucidate the structure. So these are the common things I should point out that. The first one is the basic principle that everyone know, that it is whenever if you're giving an applied magnetic field, obviously that magnetic field, it will comes to the lower energy to the high excited level. And by seeing this concept only, it will recorded your NMR spectra. Okay. So by seeing this NMR spectroscopy, this is my primary point. All magnetically equivalent nuclei will give one NMR spectra. So that is one of the very important concepts. So then I will show you that what is meant by the magnetically equivalent nuclei. Okay, so then if you're seeing the structure of a molecule, there are two things you should point out. First one is the chemical equivalence and magnetic equivalence. So these have a very close correlation. I'm just taking an example. Can you show the structure? Hello.
Yes, sir.
Yes, this is a very simple structure, that is ethyl chloride. If you're seeing the structure of ethyl chloride, so I can see you that there are two carbon atoms are there. The one carbon is nearer to the electronegative atom, that is chlorine atom, and one carbon atom is which is away from the chlorine atom. So there are, if you've seen the number of hydrogen, there are 5 hydrogens are you can see in the structure of your ethyl chloride. So then I will show you that what is meant by magnetically. So can you see my animations clearly?
Yes, so we
Yeah,
can
so
see.
this is a representation of 3 hydrogen. So these 3 representation, 3 hydrogen, I just represented by means of a blue mode. Then again, I'm taking another, my chlorine atom, and you see here, if you're seeing the structure of ethyl chloride, I can see that there are 5 number of hydrogens are there. But in that 5 hydrogen, I can tell you that there are 2 types of hydrogens are there. Okay, so the hydrogen which is belongs to the methyl group, and the hydrogen which is belongs to the carbon which is nearer to the chlorine. Okay, now I can show you that if I will see the case of all these 3 hydrogen which is in a blue mode, they are chemically and magnetically both are equivalent. That is one of the primary concept. But if you see this particular case, I'm just taking the adjacent 2 hydrogen atom which is belongs to 2 carbon. In that I can tell you that they are chemically non-equivalent, because one hydrogen is belongs to the carbon which is nearer to the electronegative, and one hydrogen belongs to the carbon atom. So that's why you can see that chemically and magnetically equivalent. This is a very classical example. I can show you that. So this is another example of an organic molecule, that is ethene. So here also I can tell you that there are 2 hydrogens are there. So in that 2 hydrogen, I can tell you that so chemically and magnetically they are not equivalent. Okay, so that's a clear concept. But if you've seen the case of your that is my yellow, I can tell you that chemically equivalent but magnetically not equivalent. Okay, so then I will make a conclusion. If you're seeing the case of an organic molecule, magnetically equivalent and chemically equivalent, there is not always, you cannot expect all your magnetically equivalent hydrogens is exactly similar with your chemical environment. So that may be not always. Then I am taking a classical NMR spectrum by means of a chemical shift. Okay, so chemical shift, as you know that this is a standard we are using, and it is extend from 0 to 12 or 11. This it represented only 10. Okay, this is a classical example. I can tell you that. Okay, 1 minute. So then the another question is what is meant by coupling constant? Coupling constant is always, I think I know that if you have seen the chemistry paper, you can see that the coupling constant is one of the major things which we should identify the nature of your hydrogen atom. Okay, so that coupling constant is always calculated by the difference between the 2 spectrum, and it should be multiplied to the NMR spectroscopy, that is the suppose if you are using the NMR spectroscopy 400 megahertz or 500 megahertz, you should multiply and you will get your coupling constant. Okay, so this is a common value. Can you able to see the common values? Hello.
Yes, sir.
Yes, if you've seen the case of your common value, this is the whenever if you're going for an NMR spectroscopy, I can tell you that always you have a what is that? There are 2 parts you can see that. First one is the shielded part. Second one is the deshielded part. If you've seen the case of your shielded part, always you can see that the shielded part is nearer to your solvent peak. That is your standard, which we are using, whether we are using the DMS or CDCl3, anything. Okay. And if you're seeing the case of another part, which is belongs to the 7, 8, 9, 10, 11. So these are the de-shielded part. Okay. So shielded part, it is always, you can see that they are methyl group, ethyl. And if you've seen the case of your de-shielded part, always you can see the aromatic, then aldehydic and carboxyl functional group. Okay, so now I will tell you that what is meant by the exact concept of shielding and de-shielding. Okay, if you're seeing the case of our HNMR spectroscopy, can you able to tell me that what is meant by proton? Anyone, can you please explain what is meant by proton? Hello, hello. Can you hear my voice?
Sir, we can hear, sir.
Yeah. Anyone, can you please tell me that what is meant by H plus or proton? Simplest definition.
It's the positively charged ion, sir. What apart from that?
It's a positively charged ion. In a simple term, I can tell you that is it positively charged hydrogen that is always, then why we are making or why we are naming as proton? Hello?
No idea, sir.
Yeah,
Please, yes, sir.
if you're seeing the case of a hydrogen atom, you know that the hydrogen atom is one of the lightest atom, or you can see in the left hand side of the corner of a periodic table. If you've seen the case of your hydrogen atom, the constitution is it consists of one electron and it consists of a nucleus. Unfortunately, the nucleus doesn't have any neutron. It contains only one charged species, that is proton. Okay, so once your hydrogen atom lose its single electron, I can tell you that remaining is your hydrogen nucleus. Are you agree with that? So if you've seen the case of your hydrogen nucleus, the nucleus is consist of only one proton. So that's why H plus is always termed as what is that a proton. Okay, if you see the case of because I just made an graphical abstract. If you have seen the case of your this one, I can tell you that electron and nucleus. So definitely there may be some distance is there. Okay, so then the question is, then I'm moving to that. If any electron, so depending upon the electron density, it will shield your nucleus. So that is one of the primary point. Suppose if your nucleus will not contains any sufficient amount of electron density, I can tell you that that will shield your nucleus. So then another thing is, if you've seen the case of your hello, can you hear me? Hello.
Yes, sir.
Yeah. So now I can tell you that. So this is one of the major concept I told that. So whenever there is a proton is there. So proton, I already told that it is a hydrogen nucleus. If your proton is protected by electron density, so that means we need they are shielded by your proton, and that shielding proton, it needs upfield. If you see the case of your downfield, I can tell you that the electrons which is the electron density, I cannot tell you that it is not like your upfield. So what means you can expect a downfield. So shielding and de-shielding, it is depends upon the electron density or electron cloud which is nearer to your nucleus. Okay. So I think I can make a very simple term. If you are using the electrons, it will always increases your shielding. If you are removing the electron, it will decreases your shielding. So that's one of the major concept I can tell you for your NMR spectroscopy. Okay, then the question is, so then the conclusion is the degree of shielding of nucleus is depends of the surrounding electron density. So that's what we are going to explain. So now I can make you another example. This is, can you able to tell me the common structure? So always this is a alkyl derivative. I can tell you that it is an alkyl halide derivative. I can tell you that X is, if it is electron withdrawing group or halogens, so always it is downfield and de-shielding. Okay. If it is X is an electron donating group, so you can expect an opposite phenomena, that is upfield and shielding. Now the rule of multiplicity. So the rule of multiplicity is a common aspect because I can tell you that in every NMR spectroscopy, you can see that it is not only singlet, you can see that singlet, doublet, triplet, quartlet. So such type of peaks you can see that. So that is typically depends upon the rule of multiplicity. I can make you an example. What is it? The rule of multiplicity, because always the rule of multiplicity, that is n plus 1. N is the number of non-equivalent neighboring protons. So I will explain you what is meant by non-equivalent neighboring proton. Okay, so these are the different types of peaks. I can tell you that what is that, a singlet, doublet, triplet. So I just made the ratio of that intensity. Okay. So this is a Pascal rule of triangle that is based upon the number. Okay, I can tell you that. Okay, so this is also a classical example of if you're seeing this particular structure, I already clearly stated that this is an ethyl bromide. If you're seeing this case of your ethyl bromide, can you able to see my slide clearly? So I just made that this particular methyl group. So how many neighboring proton, you can see that there are 2 neighboring protons are there. So this particular intensity, so the intensity of your methyl group, then the number of non-equivalent is 2, then I can tell you that 2 plus 1, you will always expect a triplet. Then I can tell you that in the case of your this particular CH2 group, the neighboring proton is 3. So N is equal to 3, then 3 plus 1, it is quadrille. So these are the rule of multiplicity of both your structure. That means your both of your compound, your compound. So now, if you're seeing the structure, so can you able to predict how many NMR peaks you can see in this particular structure? Anyone, can you able to explain? Hello? Hello? Hello?
Yes, sir.
Can you able to explain how many peaks you can expect?
Sir,
So
no
there are,
answer is coming as such. I think in public forum, people are afraid to answer.
what? I didn't understand.
No answer has come up, sir. So
Okay.
please proceed with the explanation. Thank you, sir.
Okay. 1 minute, madam. Okay, if you're seeing the structure of your this one, I can tell you that there are, what is that, how many number of hydrogen? 3, 6, 9, what is that, 11, 12. There are 3 types of hydrogen atom is there. The hydrogen which is bearing from the methyl group, the hydrogen is bearing from the CH2 group, and the hydrogen is belongs to the OH group. So I can tell you that this is a 3 types of pattern. You can see that in the structure. Okay. Now this is another example of ethyl chloride, same like that also. Here also you can expect 2 types of protons. Okay. Now this is a clear anatomy of an NMR spectrum. Whenever if you're seeing the structure of an NMR spectrum, so these are the rules we should follow that. The first one is the number of signals. So if you're seeing the case of your NMR spectrum, you can see that there are signals are there. The first one is the number of signal. So how many number of signals, it will clearly demonstrate the type of hydrogen atom, whether the hydrogen is belongs to the, what is that, belongs to the carbon, or the hydrogen is belongs to the OH, or the hydrogen is belongs to the COH. So that type of information I can get you the number of signals. Now the next what is that rule is, if you want to see the intensity of your signal, you know that the signals are there. So definitely, if you're seeing the case of a signal, sometimes some is short, someone is large. So that's why I can explain on the basis of the intensity of the signal. That means whatever the relative amount of hydrogen which can be present in the structure of your molecule, so that will clearly tell about the intensity of your signal. Okay. So then the question is, you see here, I already told you know that if you're seeing the case of your NMR spectroscopy, the type of hydrogen. Hello.
Hello,
Hello.
sir.
Can you able to hear me?
Yes, so now we are able
Yeah.
to hear you.
So now the question is that there are 3, what is a rule I mentioned, that the first one is the type of hydrogen. The type of hydrogen, always you can see that how many number of signals you can see in the HNMR. Then how many amount, what how much amount of hydrogen. So that we will see about the intensity of your signal. And the nature of the hydrogen, I already told you know that the hydrogen can be seen in the OH group, the hydrogen can be seen in the SH group. So that type of nature of your hydrogen is always you can see in the case of your position of your signal. And the last one is splitting. So splitting always will tell you that how many number of neighboring groups you can see in the structure of your molecule. So if you know all these 4 rules, so everyone can be easily interpreted. First one is a type, relative amount, nature, and neighboring group participation. So if you've seen the case of a signal of an NMR spectroscopy, you can identify the number of signal. It will tell about the type. The intensity is a relative amount. The position is the nature of the hydrogen, and splitting it will tell the neighboring group participation. Okay. So now I'm just showing an example of very classical NMR spectroscopy. Can you able to see the slide clearly?
We can see, sir.
Okay. So if you're seeing the structure of NMR spectroscopy, so can you able to tell me that I just rounded that it is C5H10O. So anyone can you able to tell me that what type of molecule it is? Anyone can you able to explain? Hello? Hello? Can you able to hear me?
We can hear you, sir.
Yes. So someone told that it is an alcohol, and whether it is a, what is that, aliphatic or aromatic? Yes, it is one told correctly. It is an aliphatic. So by seeing this molecular formula, I have some general information. The first one is can you able to see the number of carbon and hydrogen? It is 1:2 ratio. If it is 1:2 ratio, if it is carbon hydrogen, because you know that the structure of your benzene is carbon and hydrogen is 1:1 ratio. So at that particular time, the carbon can be accommodate maximum only 1 hydrogen atom. But here, the carbon which can accommodate 2 hydrogen. So definitely what will happen, it is not aromatic, it is aliphatic. So I think one faculty told right answer only. So now if you're seeing the case of, can you able to see my cursor clearly? Hello? Hello?
Yes, sir.
If you're seeing the structure of this one, I can see that how many signal, 1, 2, 3, 4 signals are there. If you're seeing the case of your 4 signals, according to our rule, I can tell you that there are 4 types of hydrogen atom. You can see that. Then the question is, if you're seeing this first one, it is what? Triplet. Yes. If you're seeing this one, what is that? Singlet, sextet, and triplet. So these are the basic information I can gather from my graph. Okay. So then the question is how I will interpret. So if you're seeing the structure of here, this one, so can you able to see that 33.2, 48.4, 33.3, 48.7? Can you able to see that? Hello?
Yes, sir, we can see.
So I can tell you that that's why I told you that if I will apply my second rule, the relative amount, it will classically, it will tell about that, what is that, how much amount. Now you just take the least value, that is 33.3. Then you please divide it by the first one, that is 33.2 divided by 33.3. What is that? You will get 1. Then here it is 1.5. Here is again 1. Here is 1.5. So I think the ratio I just clearly explained, 1:1.5 1:1 again 1.5. So total 5 hydrogen. So 5 is your total value. So please multiply into 2, then you will get what is that? 2:3:2:3. So that means now I can tell you that there are 4 types of hydrogen atoms are there. These 4 types of hydrogen atom, maybe it is belongs to the carbon, or maybe it is belongs to something like that. But can you able to justify the one thing is what is that? It is because one fellow already told that it is an alcohol. It is not an alcohol, because if it is an alcohol, so definitely I can expect a ratio 1 because alcohol is ROH group. The hydrogen is belongs to only one hydrogen atom. But if you're seeing this particular ratio, I can clearly tell you that 2:3 is to 2:3. So that is your hydrogen can be accommodated in which carbon atom. So then the question is, if there is no OH group, there is no COH group. So then I can tell you that that oxygen is belongs to either aldehyde or either ketone. Okay. So now the question is, then I can tell you that what is that? This is a classical formula of alkane. What is that? CnH2n plus 2, that is 12. If you are seeing this particular molecular formula, what is that? So obviously it needs C5H12. That means 2 hydrogen is lacking. So I can tell you that hydrogen deficient, that is 2, that is 1 pair of hydrogen. So then I will show you an example because this is the first structure. What is that? CH2. If it is CH2 group, I can tell you CH3. I can tell you the CH2 group and CH3. So that means, so I can tell you that very clearly that is, what is that? 2:3:2, 2:3. So then the structure is, if CH2, it is triplet, because here it is appears as a triplet form. If it is triplet, so what is that? N is equal to your neighboring proton should be 2. If it is CH3 is what is that? Singlet. Singlet means your adjacent proton should be, there is no equivalent proton, sorry, non-equivalent proton. So N is equal to 0. If you have seen the case of your CH2 group, I can tell you that you have a sextet character. So definitely, if it appears as a 6 splitting, so definitely the neighboring proton should be 5. Then again 3, again you know that the neighboring proton should be 2. Then the molecular formula is very clearly, you can see that it is a, what is that, a very famous ketone 2. What is that? You will get the structure. The first one is the CH3 group, that is belongs to this one, then CH2 group, then CH2 group, and finally CH3 group. So this is a simplest interpretation I can repeat you. Then again, tell you the this structure. Can you able to explain? There are 3 signals are there. So anyone can you able to judge what type of structure or what type of molecule? Anyone? Please, you can type in the comment box also. Anyone can you able to? Hello? Anyone can you able to tell me? Hello? Hello? No one is there. Hello? Hello?
Sir, we can hear you, sir.
Anyone can you able to
Alkane
type?
answer has come in the chat box.
Anyone can you able to tell me? Any faculty, please type that what type of structure this one. Okay, I will explain you. If you're seeing the structure, I can tell you that C8H10. If you're seeing the case of your C8H10, so definitely the first concept is, you see here, I can tell you very clearly that it is typically an aromatic compound because the carbon hydrogen ratio is almost same. Okay, but it is not same, 1:1, but you can expect it is almost same. So then the question is, if you're seeing the case of your if you're seeing this particular structure, I can tell you that what is at C8H10. So you can expect 18 protons. But unfortunately, you have a lack of what is at 4 pairs are there. Hydrogen deficient is 8. So that means 4 pairs are missing. So then the question is, if 4 pairs are missing, I can tell you that this is a multiplet because according to a rule, if it is multiplet, definitely it is belongs to the aromatic. So I can tell you that the arch hydrogen is belongs to the benzene structure. Okay, so then the remaining is very simple. So then if you're seeing what is that, counting that splitting, it is appear as quarterlet. What is that? So your adjacent is should be 3. And if you're seeing this one, your adjacent should be, what is that? 3. Okay, so now can you able to justify your answer clearly? Anyone can you able to type in the chat box? Now almost you have a very clear idea about that. The one is triplet, another is quarterlet. Then what type of structure? Because already we solved the structure of benzene. Then you need other 5 more protons? Anyone can you able to tell me? Please type. So I can tell you that it is belongs to the CH3, it is belongs to the CH2 group. So the structure is, what is that? It is ethyl benzene. Can you able to follow the, what is that concept clear or not? Hello? Can you able to?
Sir, someone has answered in the chat box as ethyl benzene.
Yeah, but
Can-
I can't see that.
Yes, sir.
Yeah. So now I will show in another example, C9H10O. So anyone can you able to, what is that, interpret the structure within 1 or 2 minutes? Very simple structure. In the comment box, or you can tell manually, there is no issue. Hello? Hello? Anyone can you able to explain?
Sir, the delegates are they are getting this live streaming of YouTube. So as such, sir, they will not be able to answer verbally, but definitely through
Yeah,
chat box only they can communicate,
but
sir.
in chat box I can see. Okay, then I will explain. Okay. If you're seeing the case of your this one, I can tell you that there are 3 types of protons. I can tell you that, but the one proton, it is belongs to the 9 and 10. So definitely we know that if it is 9 and 10, definitely it is an aldehyde proton, because you know the graph of a shielder and de-shielder proton. Okay, so that aldehyde proton, definitely it is CHO group. Now, if you're seeing the case of your CHO, then I solved the first singlet in a CHO group. And then I can tell you that 5 hydrogen, that is in a multiple, definitely obviously it is below between 7 and 8. It is obviously it is belongs to the benzene. So that is also, then I interpreted my structure, because now I interpret the structure of CHO group and benzene. The last is, what is it? Adjacent 2 triplet. So then I can tell you that, what is that? This is a structure. What is that? CH and CH. Okay, so these are the concept. I can tell you that. Then I'm just joining with your A and B. You will get your structure. So the structure is very simple. What is that? 3-phenyl propane aldehyde. Okay. So CHO group, that this particular CHO group, it is belongs to the first one. Then the CH2 group adjacent is 2 hydrogen. So that is triplet. Then this CH2 group is adjacent is contains 2 neighboring protons. So that is also triplet. So 2 triplet protons can be seen in that both carbon belongs to the 2 hydrogen atom. So you will get your structure. Okay. So this is another example. So this is also a very simple example. I can tell you that. So now you just count your molecular formula is CnH2n plus 2 is equal to 20. Then definitely, if it is 9, you can expect a 20 hydrogen atom, but unfortunately 10 hydrogen is missing. That is hydrogen deficient from this molecular formula is 10. That means 5 hydrogen pairs are missing. Then the same rule divide with your least one, that is 23. Then you will get 2.5 is to 1 is to 2 sorry 1.5. So this is a then you multiply into 2, you will get your 5 is to 2 is to 3, that is 10 hydrogen. So no COH group is there, because so that's why I can tell you that there is no singlet group in the between 10 and 11. So that means absent of COH group, absent of CH group. So definitely, if you're seeing this particular, definitely multiplet, definitely it is benzene ring. Then 2 hydrogen, and so this is another classical example of ester derivative. Okay, so this is an example. Then the NMR spectroscopy with the knowledge of functional group. So this is another classical concept, because there are so many concepts. You can see that once you know the molecular formula, the NMR spectroscopy can be identified. So this is a knowledge of functional group. I actually, my hint is, I am just giving the structure of a molecule. Then I am claiming that this structure is a ester. So there are 3 types of peaks are there. Then I will make you an example. If 3 hydrogen, definitely what is that? I can tell you that 3 peaks, 3 types of hydrogen. So can you able to see any aromatic peak between 7 and 8? No. So definitely I can tell you that this ester is an aliphatic, because all the aliphatic, that is CH3 and CH2, is belongs to the shielded part. So if you're seeing the case of your compound is an aliphatic, definitely I can tell you that there are 3 peaks are there. So then I will interpret. Definitely by seeing the 3 peaks, there is no shielded part, that is 7 and 8. So absence of aliphatic. So sorry, absence of aromatic. Then if it is aliphatic ester, I can tell you that then skeleton should be CCC. That means that there are 4 number of carbon atoms are there. So then the question is, because if it is an ester, it is RCOOR. So that means that carbon doesn't contain any hydrogen atom. That's why I made a skeleton of 4. Then the A type, B type, C type. There are 3 types of protons. I can see you that in the A type proton, I can tell you that it is sharp. You can see that singlet. That means if it is singlet, definitely your adjacent number of non-equivalent proton is 0. So neighboring proton is 0. So that's why that neighboring proton is 0. That means then it is appears as a singlet. Definitely it is hydrogen should be 3 in the case of your A. And definitely it is CH3. And I can tell you that CH3 belongs to the COO. And second is what is that the N is equal to, you can see that it contains quartet. If it is quartet, definitely what will happen? The number of neighboring proton is 3. So that's why it is appears as a 4 splitting pattern. If it is 4, it is CH2 group. Then the last one is what is that? N is equal to 2. It is triplet hydrogen. So then your structure is what is that? Ethyl acetate. Okay, CH3 is belongs to the this particular group, and the CH2 is belongs to the second one, and the last is CH3. The neighboring proton is what is that? Neighboring by 2 plus 3. It is this is a structure of the simplest definition. And this is another example of a molecule. So here, if you're seeing the case of this particular hydrogen atom, sorry, particular molecule. So I can tell you that there are 3 types of hydrogen atoms are there. 2 types of hydrogen atom. It can be beer from the benzene, and 1 methyl group. It belongs to the functional group. Okay. Now I can tell you that singlet with the shielded, because all the basic concept only. Then this is another what is that? NMR spectroscopy of that particular molecule. Then CH3 belongs to the singlet, and this particular hydrogen belongs to that nest aromatic. And I can tell you that these are the different types of. So interpretation of if you're seeing the case of your because why NMR spectroscopy nowadays, if you are submitting any Medcom related article, so identifying NMR spectroscopy is one of the major tool for the structural elucidation. Suppose this is my thing. If you've seen the case of your A plus B, you will get C. C is your product. Along with your C, you can see some impurities in any organic synthesis. Maybe that impurity belongs to the unreacted A or unreacted B, or maybe the intermediate of AB. Maybe the intermediate of AB. So the many things you can see for the example of what is it? In the case of your interpretation of my own molecule. Okay. So now the question is, if you want to before going for the any, because in my lab, so we have a flash chromatography is there. So whenever what is my suggestion is, once you synthesize a molecule, the first one is you please thoroughly wash with any solvent which should not be soluble in your substance. Okay, you please wash with the water or any solvents which is used for the synthesis. After the washing, you please proceed for the recrystallization. After the recrystallization, you can go for your flash chromatography. So if you are getting a single spot on the flash chromatography, then you can go for your NMR. You will get a very pure spectrum. Okay. So this is one of my article, which is I published in the 2018 in RSC Medicinal Chemistry. Okay. So this particular
Sir, sorry to interrupt, Dr.
Yes.
Matthew.
Yes.
Sir, you have another 5 minutes to conclude, sir.
Yeah. The last one.
Thank you, thank you.
Okay. So if you want to see the structure, I am just showing the example of my NMR spectroscopy. This is synthesized from my own lab. Then I will tell you that you please divide it by the same rule which I already told you know that that is 1.37. You please divide it into 7 types of proton. I can tell you that. The first one is the CH3 belongs to the NCH3 group, that is this particular area. Then NCH3, that is this particular one. Then why NH3? Because that is because I'm just asking a question. You can make the comment box. Why NCH3 is more shielded than the these two hydrogen? Okay. Then this is belongs to the aromatic. This is belongs to the NHCH3. This is belongs to the aromatic. Then the last one is what is that? That belongs to the. This is I can tell you that imine protein. So these are the classical example. Then this is a classical representation of NMR spectroscopy. When you are going for a journal publication, you should write the IUPAC name, then the code of your molecule, then H1 NMR, then the which megahertz they are using and which solvent they are using, and next is the parts per million, that is a unit. You can always starting from the shielded proton to the de-shielded. You can always if can you able to tell me that if you're seeing the structure of your this one, I can tell you that what is that HNMR spectroscopy. I can tell you that 2.89 to the shielded to the de-shielded. Okay, so this is my scheme. Okay, there are so many examples. I think due to the lack of time, I can conclude that my session. Once of all, I will thanks to the university for and the faculty members and HOD for giving an opportunity, because NMR spectroscopy, I know that it is very difficult to finish within 1 or 2 hours, definitely. So by seeing the all the spectroscopy only, you can able to identify whether the structure can be, what is it, how the way of structure. Suppose if you have any doubt for the NMR spectroscopy or interpretation, you can happily, you can mail me. So definitely our team will be definitely contact with you for any further structural elucidation of your molecule. Okay, thank you very much.
Thank you very much. Thank you, sir. Thank you, Dr. Matthew, for very passionate explanation about this very vital foundational topic, that is interpretation of NMR spectroscopy. So it is part of any analytical project as well as other projects for characterization. It is very much required. Sir, you covered multiple examples and tried to simplify the topic. So very thankful to you, sir.
Thank you, madam. Thank you.
Dear Dr. Matthews, thank you for
Sir,
joining.
sir, how are you, sir?
Thank you. I'm good. I'm actually in a transit.
Okay, sir.
So yeah. Thank you for joining. Welcome, Dr. Bongade, sir. Welcome.
Yes, sir. Yes.
Dr. Matthew, we would like to, as a token of our respect and gratitude, we present you with the certificate for being
Yes, sir.
resource person for the event.
Okay. Thank you, madam. Thank you. Okay, thank you.
I hope it is visible.
Yes, madam. Okay, no problem.
Thank you so much, sir.
Okay,
and
madam. Thank you.
have a great day, sir.
Okay, thank you, madam.
Moving on to the next session, it is our privilege to have with us another significant personality, Dr. Bhumendra Bongade, as our next resource person. Dr. Bhumendra serves as a professor and chairperson in the Department of Pharmaceutical Chemistry at RAK College of Pharmacy, RAK Medical and Health Sciences University, UAE. With over 20 years of academic experience in India, Malaysia, and UAE, he has made significant contributions to the field of medicinal chemistry and pharmaceutical education. Dr. Bhumendra earned his PhD from RGUHS Bangalore and completed his postdoctoral fellowship at the University of West Indies, Trinidad and Tobago. He holds a Master of Pharmacy in Pharmaceutical Chemistry from Karnataka University, Dharwad, and a Bachelor from RTM Nagpur University. Sir is recipient of the prestigious Senior Research Fellowship during PhD from Council of Scientific and Industrial Research, New Delhi. His academic portfolio includes 2 patents, US and Indian, 4 review articles, 2 book chapters, and over 26 publications in medicinal chemistry and drug design, and more than 35 conference presentations. His primary research interests lie in chiral drug synthesis and synthesis of small molecules as selective enzyme inhibitors targeting cancer. Dr. Bhumendra's dedication to research and teaching has earned him a reputation for fostering innovation in pharmaceutical sciences while shaping the next generation of professionals in the field. We are humbled by your presence, sir, such an established researcher among us. Heartfelt welcome to you, sir, and we invite you to deliver the address. Thank you.
Thank you, ma'am. Thank you, and thank you for the invitation. Thank you for my old friend Rakesh for giving me this opportunity to present some of our teaching techniques that we use, and it's really not common in India. So I'm just introducing you all with all the audience with a new technique. I might have definitely heard about it. My slides are visible, ma'am.
It is visible, sir.
Okay, because I have not seen my slides, so just,
It is visible, yes.
I'm not able to see.
Yeah, visible.
Is it in the presentation mode?
नाही अजून मुवमेंट झालेली नाही स्लाइड्सची.
1 minute, we'll see that. We'll try. Because I am not able to see my screen. Okay, with this. So just you can direct me whether it is in presentation mode or no.
Sir, not yet in presentation mode. Slides are seen, but not in presentation mode, sir.
Okay, I'll just share actually. Let me try. I'll stop sharing.
Maybe sir, you can de-share and again reshare. You can
Yeah,
try
yeah,
accordingly.
exactly that is what I'm doing.
Sir, please press escape. Bhumendra sir.
Yes.
Yeah.
Okay. Done.
Now can you see your screen?
I'll share it right now.
We are just able to see your screen, and this Slido also, which is there, which you can see.
Let me try. Because I am not able to see that. I'll just close it. I'll close my screen. It is closed now.
Yeah, currently closed.
Currently closed. Okay, so I will try to share it again. Okay, is it fine now?
Slide is seen, sir.
Not in the presentation mode?
Not in presentation mode.
Just Just I'll call my colleague, to help me in this
Yes.
couple of minutes. Sorry for that.
No, it's fine, sir. Sir, you may proceed. Means I feel it can be seen, sir, like not very difficult to see.
Okay, okay. Then I can proceed like this? No problem. Just let me try one.
Means meanwhile, if we can come and still till then you start something like
Exactly, I'll
that.
do that. Yes, Ati, can you just help me in just sharing this PPT? Yeah, please, please. Yeah, please. Okay. No, but it is not showing like the full screen, no, full screen. Yeah, okay. Is it in full screen mode now?
Not in full screen mode, sir.
Not it, sir.
So here, full screen is there, no? There, sound, okay. Screen is like that.
Sir, maybe you can press escape and then via Zoom. Yeah, it is
Now,
full screen now.
now it is.
Okay.
Yes,
I can, okay, I can close this now. Right. Meeting control, right? Okay. That's good. Okay. Yeah, it's fine now.
It is full screen now, sir. Yes, sir.
Okay, so I can move to the next slide. Just can you check it? My studio. I will get. Okay. Okay. Right. So I'm sorry for that. Just I'm sorry for that delay.
No,
It's a
sir.
technical
Absolutely
growth
fine,
always.
sir. Yes, sir.
All right. So I'll be, discussing the team-based learning. Relatively, it is a new concept. To the best of my knowledge, that most of the universities in India, they are not using this kind of additional teaching tools. Like, we are more of like a classroom teaching. So, okay, we'll just go to wrap up. I'll try to wrap up this session around 40 to 45 minutes, and we'll try to. Anyway, I cannot justify this topic in 40, 45 minutes, but I'll try my best, to actually give and just introduce this topic. I can say just I can introduce this topic to the audience. Okay, so this is you know the some kind of like a poll that audience can scan this QR code, and if possible they can answer. We can take another 1 minute or 30 seconds for that. So
Sorry, sir.
audience can scan this QR code,
Okay, sir.
and they can participate in poll.
Okay, sir.
So maybe 30 seconds or 40 seconds we can wait for them. So they
Fine, sir.
can choose the more than one answer. So this is related to the like what teaching strategy to the currently used to engage students in the classroom. Okay, so we'll just wait for the participants. Problem based good. Some people are using problem based. That's nice. So I'm talking about the current strategies, what they are basically using in the classroom. I'm not talking about the TBL, whether it is a problem based or no. What are the strategies? So one of the strategy I can is the lectures. No, we give the lectures to them. We can wait for a few more participants before we move on. Good. There are people are using this experiential teaching like field visits. That's nice. Industry visits and the community visits. Okay, that can be engaging them with the ICT tools. Okay, good. Explaining SAR and with the SAR maps. That's nice. Solving problems. Good. All right. So like talk and talk. Yeah, that we are using PPT presentation. Yes, of course. And problem-based learning. Okay, that's nice. Okay, we'll move to the next part of this. That is, do you have ever been a part of any team-based learning, okay, or learning activities? Experience as a student in the instructors? Yes, that's good. Almost many people are, saying yes. So they have the experience in team-based learning. So why I'm asking this question, because whenever we introduce new technique, usually people they resist, even the students and the faculty they resist. So if they are already in like using this learning different learning activities, of course we'll have that opinion, no? We'll have that acceptance of the people will be there. Yeah, wow. So almost many are yeah, around 80 per 13% they are saying yes. So still fair, no issues. At least majority of them, we are actually using this. Fine, that's good. Okay, number is increasing for us now. It's okay. I'll just move on. Okay. Anyway, this is just a brief idea that majority of the people, they have been a part of team-based learning or the teaching activities, experience. Okay, good. Right. So it can be also 50-50. No issues about that. Okay, we'll just move on. All right, so this is my learning objectives for the class. So what I expect at the end of the lecture, the delegates will be able to explain the structure of TBL implementation. They will recognize the basic principles of TBL, evaluate the impact of TBL on the student learning and the performance. That is very much required because nowadays the students are well equipped with the various AI tools. Okay, so we have to look into this various structural student learning and performances. Develop effective TBL activity, yes, and the application exercise that is very much important. It's a faculty development, and I expect that there are many faculty. So I want, that is also my one of the learning objectives. So people should able to at least start thinking on developing the TBL activities and the application exercise. So this concept of TBL was developed in 1990 by Professor Larry Michelson. So he was the professor of business school, and he has a class, in Canada, and he has a class of more than 250 students. So he is the one who thought of starting how we can make the classroom more interactive, and maybe you can divide the students in a small group so they can initiate the discussions, and it can be more of like learning instead of like a passive learning. So what he defines TBL as active learning process. So it's the involvement of the students that makes it active and small group. So students of 200 or 100 students can be grouped, divided into small groups of 5 to 7. It's the instructional test strategy that provides the students with the opportunities to apply conceptual knowledge and sequence of activities. So very important, in this case, in case of TBL, there is a sequence of activities. What are they? Sequence? That's the individual work, teamwork, and the immediate feedback. Okay, so I will just go through these various sequences and the strategies of the TBLs, in the next few slides. So who is basically using? So I told this was developed in 1990s by Professor Michelson. That he was in the business school. Then it has been implemented in 2000 by Bayer College of Medicine. And then after it has been used in various medical schools and the business schools and other schools also. Okay, and the pharmacy schools as well. So as a innovative teaching methodology. In my university, we implemented in 2013. TBL we have implemented, yeah, 2013 we have implemented. So these are the few universities, few universities where the TBL in pharmacy schools have been implemented widely. Right, I'll not go through that. So why actually we need, the alternative teaching tools, and TBL is one of the alternative teaching strategy for the classroom teaching. So what you need, because as a faculty, we face a lot of challenges in the teaching in the classroom nowadays. Sometimes the students are with the mobiles and they are not, actually they are not very much attentive in the class. So few things like passive learning, that is a challenge. The students classroom teaching is a passive learning. And there are lack of engagement. Students we don't they are not engaged in the classroom. So usually we go and we deliver lecture and that's it. Okay, sometimes we ask some questions and some maybe some students and they reflect. So there is no actually lack of engagement. And these are limited peer interactions. We don't allow them to discuss with the with the friends during the class, during the regular classroom. So these are the various challenges: passive learning, lack of engagement, and limited peer interactions. So that is why the PPL, TVL, it offers a lot of benefits. So basically, it is a student-centered teaching technique. It involves all the students, very actively in the learning, and it can improve the critical thinking of the students, and it can even enhance the communication skills of the students. So these are the various like benefits that TBL can offer to the students. Okay, regarding the core principles of the TBL, in core principle of the TBL, we have like a team readiness assurance, application activity, feedback, and the peer evaluation. So these are the core principles. So teams basically they are the diverse and the permanent group. So actually we start TVL in first semester of the curriculum. Okay, and we make the team of the students and we try to retain that team until they graduate. Okay, so almost for the 4.5 years, they have the same team usually. And we try to make it as a diverse team and it's a permanent team. Because in readiness assurance, it is a kind of, I can say, a speech. So usually we give them some MCQs in the form of MCQs. And students, they need to prepare themselves before they come for the TBL sessions. So TBL session, it is actually start 1 week before for us. So usually we send them the study material, we send the learning outcomes at least 1 week before. Okay, at least 1 week before. So they prepare. When they come for the actual teacher session, they come prepared because they have to learn. So we start with the readiness assurance test. So just to ensure that whether they came for the prepared or no, okay, we take the kind of like a multiple choice questions, 10 to 20 multiple choice questions, and they answer individually. Okay, that is called as a IRAD. Then once they finish, then they form the team with the teams and they answer the same same MCQs. Okay, so that is called as TRAD. So that is the readiness assurance. We have IRAD and the TRAD. Okay, once we finish this readiness assurance and the feedback by the faculty, okay, we move on to the next session, that is the application activities. Okay, so it is focused on the real world problems. And finally, it is expected that we should give them the feedback very frequent and the immediate feedback. Okay, not in the classroom or any other test. Suppose we carry some sessional exams or other tests. Students have to wait for their results to be declared maybe after 1 week or after few days. After few days, but here in case of TBL, they will know their grades and their marks and what they scored immediately. So that is the advantage of this TBL. Okay, and then the peer evaluation. Peer evaluation is also one of the very important component because it makes them accountable. All the teams. So they expect that all the team members they will be like they'll be contributing for the team activities. So peer evaluation is a really important component of this TBL. Okay, we'll talk about the TBL process. So there are 4 phases of the TBL. First, start with the preparing in-class, pre-class preparation. So at least this starts, I told you, almost 1 week before we send them the text. So it is pre-class. Then the readiness assurance. This is during the actual TBL session. Then applications of course content. That is also during the actual TBL session. And we have a peer review and feedback session after that. So this is completes this whole TBL process. Right. So pre preparations or the like a pre-class preparation. So it is again driven by the various learning outcomes. So what we do as a faculty, we select some topic, select some topic, and then we select the appropriate learning material for that. It can be maybe a textbook, it can be a video, or it can be a PPT. So there is no limitation, anything, or it can be a mix of this. So all these learning outcomes. So learning outcomes based upon that particular topic, we have to communicate to the students. So students, they know that what actually they have to focus, where they have to focus, how they can study. This helps them into for the preparation for the RAT. Okay. Right. Then once they come to the class, we take the individual test that can be in the form of MCQs. Usually it is in the form of MCQs. So they write themselves. Okay, write. They answer all the MCQs. Okay, and then we have team rats. So they mix up with the team. They form the team, and then discuss same MCQs. Okay, in the T-rat, and always, this again team up is because in the T-rat and the I-rat we try to keep very challenging questions, very confusing questions and challenging questions. So sometimes it's difficult actually, to for them to come to some common answers, and they will have the conflicts and they will try to clarify. So they can appeal also. Sometimes they can say that whatever the answers you said, what is correct in TBL, that may be wrong. So there is like a lot of like discussions in the appeals. Okay. And the faculty finally discuss each MCQs or each questions, one by one, and give the feedback. Sometimes we give it as a mini lecture also. So based overall, this like sometimes they found this topic is easy, they will not come with lot of appeals. In that case, faculty also present some kind of like kind of mini lecture, giving the some briefs and all. Okay, so that's important, component that is called as a team application activity. So this is a really important event. After the RAT, so the students again they will have this team application activities. So it's a main event, and where the teams also they come together, they discuss the very critical problems, they talk and they tackle the complex challenges. So in this case, we do provide them with the like some big and the messy, very authentic problems. That is usually a real life scenarios. Some kind of case studies. Usually we provide the case studies, and based upon the case study, we ask them to answer. Ask them to discuss certain things and certain learning outcomes and present it to us. Okay, so what happened in this case? The students they are involved in the problem solving. They spend a lot of time. Usually it is 45 to 50 minutes, or sometimes 30 to 40 minutes of time they spend to for the problem solving, and then when they solve problems, they have to report and they have to discuss. So all the teams they will report and they will discuss the solutions. Okay, with the other groups. Okay, we can use this. As a faculty, we can use 4S framework. 4S framework. So this 4S framework, it is like a guidelines. Give us the guidelines for us to how we can design the team application exercise. We'll see that what are these guidelines in brief. So first one is like a significant problem. So what are the problems you are giving? It should be very much significant. It should be a real life scenario. The students also should think that I should get some interest, and they should be also curious about that problem set. Okay, how to solve that issue. So very much important in this case, the significant problem. So that is the first case of this framework. Then you have the same problem. So problems will be same. No, not all the like different teams will give the different problems. No, we have to give the same problem for all the teams and let them solve in that team, and then okay, that is the same problem for all the teams, so they can compare the performance of their team with the other teams. So again, it's the competition between the teams. Okay, and specific choice. So again, based upon this application part, okay, we need to give them some specific choice. For example, a multiple choice question. So team no can they can answer answer. So and they can compare between the teams. So specific choice is very important. We cannot keep the open-ended questions. Right, right. We have to give the choices. Maybe you can give 4, 5, 10 choices up to us. as a faculty, we can give any number of choices, but they have to select it. Okay, they have to select from these choices. And the simultaneous reporting. So usually, the students, they all the groups, they report simultaneously. Say for example, you are asking for the very specific choice, so we'll use some kind of flag cards. So they will raise flag card. Flag card will be like options A, B, C, D, E, whatever. Okay, what are the options based upon the choices we give? So they will raise. And if it is same, then we can ask each group also that why it is why they reached that particular answer. If there is a difference in answers among the different teams, okay, so we can ask that why they have choose that options and all. So ultimately, what happens is it creates kind of like a discussions and a debates among the teams. So they will start debating with each other that they are right, other team is wrong. No, they have to prove that they are right. So ultimately, it creates excitement and the engagement in the classroom. So that is a big purpose of these application activities. So significant problem, same problem, specific choice, and the simultaneous reporting. So these are the four A's for the application activities design. Okay. Correct. So we can have clear review feedback. That is another important component of in another component of peer review feedback is another important component for this. So this is also very important and also debatable. Sometimes we say that okay, students are giving their friends full marks, right? Full marks. So it was debated that what is the fun of keeping this peer review feedback? Always debatable. But as per the guidelines, it is required to have the peer review feedback. It's very much important. So another thing is that it reflects the individuals and the team performance. And we can use the structural rubrics. In order to minimize the bias, we can use the structural rubrics, and we can encourage constructive criticism. So we have to train students. We have to tell them that if you have any personal differences, you have to keep it aside, and you can give the very constructive and encouraging comments to other peers. Right. So this paper, you can, if you are really interested in to know, why these pages are very much important. Okay, we can go through this paper, and we can find out. It's very good paper. It's very good paper. It's available online. So you can see that various highlighted. These have highlighted the importance of various pages. So each page is important. So that as I said, the peer review. Is it important? Yes, it is important. Okay, so we can find some nice explanation why these pages are important for the TBL. Right. So this is how very short video. It was recorded in 2016 during my one of the TVL classroom. It's very old video actually. So students are just preparing, before the TVL session. So they are maybe revising the content. Revising the content. Yeah. Then they go to the classroom for the readiness assurance test. Start with IRAT. So they need to answer the MCQs. We use usually bubble sheet. Nowadays we are using the computers. They go to the online computers are using nowadays. Earlier we used to use pen and paper, scratch cover sheet. Okay, once they finish IRAT, then they just assemble other teams. They make their own will in their team. And they will answer the same MCQs what has been given during the IRAT. Okay. This is the feedback simultaneous reporting. So we'll use the flash code. Once we complete, then we will go for the feedback. We'll discuss all the MCQs one by one. We give them, and here also they have a heme appeal. That is how the TBL process goes. Very old video actually. So these are the four components of TBL. To start with carefully formed and managed team, treatment and family feedback, followed by problem solving and the student peer evaluation. So these are the constitute the main four components of the TBL. What benefits this TBL it offers to the students? Of course, it increases the engagement in the classroom and motivates them for the learning. It improves the critical thinking and problem solving for the students. It enhances the deeper understanding of the course content and develop teamwork and the communication skills. So these are the various, some of the benefits that TBL can offer to the students. And for the faculty, okay, we have to use various strategies, to for the effective implementation. And it is really a challenging task. When you started with this TBL, okay, we also learned with a lot of experience. So and our mistakes. So most important thing is this, we have the very balanced teams. We cannot have the team with the like all the good students or all the girls or all the same gender in one team and all. We have to have a very balanced team. So usually what we do, we take based upon their grades the GPA, you keep in each team like good grade, medium grade, average grade, girls, boys, different nationalities, like that. So we try to make it, the teams which should be very much balanced. Then we can design high quality, application exercise. We can design, then establish a clear roles and responsibilities, so we can assign or they can assign themselves. We can motivate them to assign the responsibilities. So maybe in first semester we'll have one person who will be the leader of the groups, and one other person can be the recorder, and maybe another student can be the timekeeper. So they can assign the different responsibilities, and it can be also rotated. No, we have to encourage them to do that. Then provide the clear guidelines and the expectations. So we have to provide clear guidelines. So learning outcomes, it should be very much clear. So based upon the learning outcomes, they know that what they have to prepare and how they have to prepare. Okay, and most importantly, we have to offer the training to the instructors. So instructors, these are the ones who are the facilitators for the TBL. So for the training, and they should know the process. They should know how to how to address the student concern, because we have to give the immediate feedback. No, we cannot say that we will go back and I will see and I will give you what is correct and what is not correct. No? So this is instructor training is very much important. The faculty also has to be very much prepared, for that TBL session. And the when we want to implement, actually, we can implement. We started 2013. We started with a few courses. We have not uh, started with all the courses. We have adapted for the few courses. Then we have scale up for the other courses. And sometimes we use it as an integrated with the other courses. So suppose, for example, medicinal chemistry, we do integrate with pharmacology whenever possible. Even the pharmaceutical analysis, it can be integrated with pharmaceutics. It is not like the one course. You can have the multiple courses. Maybe medicinal chemistry can be integrated with therapeutics and other courses. So we can implement, based upon the requirement and the convenience, you can say. Okay, when we are designing any effective TBL activities, we need to follow the 4S. That is very much important. We have to follow the 4S. We can align the activities with the learning objectives. So we have to frame a very nice learning objectives. So that is challenge to the student, and we can use the real world and very complex problems. They're not the very simple problems, so they will solve and they will answer in 2 minutes and they will get off the TBL. But no, we have to ensure that the task requires the collaboration. It's a team, and not only the one person who is leading the team. Everyone should, there should be something like, everyone should able to participate in the activity, and we have to provide the clear guidelines and the rubrics for that. So we are clear for the peer evaluations and the other evaluations. We have to provide the rubrics and the very clear guidelines. So best practices for the facilitators, okay, because they are the facilitating TBL process, so they have to be like, very much prepared to facilitate the TBL process very effectively, because students will ask for the so many questions, and they will challenge, okay, during the TBL session. So they have to be very much prepared. So they have to facilitate. Again, you can see that some of the students, even though they are in the group, they may not participate. So we can encourage participants. So it is not like that. You have to go and see each team what they are doing, what they are discussing. You have to sometimes intervene with them. You have to ask them what exactly they are doing, how they are going, and what you have to see that actually which direction they are going. They are going in the right direction, or maybe the different direction. Okay, most importantly, you have to manage the team dynamics and provide the timely and the constructive feedback. So that is what we expect as the best practices for the facilitators. And yeah, I told you about this, that forming teams is very much important. The team size usually, some people they say that it can be up to 10 or maybe 2 to 5 also, but no. But ideally, the team size should be 5 to 7 members, because you have two small teams and two large teams. So it is very difficult, to actually evaluate the members and see the like the dynamic, maintaining the dynamics of the teams, and also really difficult in that case. Okay, so then we have to ensure the diversity, skills, and background. That is what we see, that different ethnic diversity. Okay, maybe they are like grades, different grades, mid grade, high grade, low grade. So we have to mix up that teams. To keep teams consistent throughout the course is very important. We cannot usually do not encourage, any team to be changed. Sometimes the students they come and ask that, okay, I don't like working with them, or something they want to change. We do not accept that. We say that no, you have to learn, how to be with cope up with the other team members. You have to adjust yourself. Okay, you have to talk to your team. You have to, any disputes are there, you have to discuss with them and come to some common consensus. Okay, and then we can assign, or they can assign themselves. Okay, usually we don't assign. We ask them to assign the roles. So maybe they can select their leader. They can select their a person who can record and who can keep the timing down. Because TBL sessions again is a time bomb. Usually we have 2 hours of TBL session. So IRAT usually it is for the 15 minutes, because we give 10 MCQs, so 15 minutes time for the IRAT. Then TRAT we give them around 30 minutes of the time, and the remaining time for the feedback and the activity. So it's a time, we have allocated time for the TBL for each course in the timetable, weekly timetable, 2 hours. So application activities already we discussed. We have to follow the 4S. So it should be focused on the higher order thinking, like for example, analysis, synthesis, and the evaluation. So that it should be the challenging, all these activities should be challenging to the students. And if it's challenging only, then they will able to, discuss, and they brainstorm and, debate. So that is what the purpose is of the TBL. Then use case studies, simultaneous case studies, real life, world, real life scenarios and simulations also. Sometimes we can give them some simulations, okay, real life world scenarios. We can encourage debate and the discussions. As a facilitator, we have to manage this. We are the ringmasters actually in the circle. So we have to encourage students to debate and discuss, because the student mentality sometimes they want to escape the things very fast. Okay, they don't want to stay for 2 hours. They want to finish in 1.5 hours. Okay, so they try to. We can involve, we can involve with them and ask them, so many big questions, and ask them to start discussions and all. And we can provide immediate feedback. That is the most important thing in this case. We can provide immediate feedback. That's the mandatory action here, because before the class they know that how much they scored in this particular TBA. And in my university, we have 20 to 30%, because the recent batches you have 30% weightage for the TBL, and previous batches like second year and final year, up to final year, they have 20% of the weightage. And this is a part of in-course assessment for us. Right. So challenges, we have many challenges. Some of them I don't want to discuss many challenges, but I will discuss some of the challenges that we face. Okay. Maybe resistance to the change. Specifically, I'm talking in context of the Indian scenario. Indian scenario. Traditionally, we are like a lecture-based teaching. We are like going we implement it. Okay? So of course the faculty and staff may like resist. Yes. So what we can do, we can conduct the workshops and the training sessions. So we can demonstrate the benefits of the TBLs and address their concerns, if any. Then lack of faculty training, yes, sometimes many of us, we have seen that from today's poll also, at least 30-40% people, they are not really familiar with these processes. Okay, so what we can do in that case, we can have a comprehensive training, and the resource training for the faculty, workshop for the faculty, for the TBLs, okay, for the principals and the implementation. So that is how we can train our faculty, okay, for the TBL session. And most importantly, again, the education in India, it is again regulated by various governing bodies, for example, PCIs and the universities. And they must have their own guidelines. I know that they have a particular thing, how much will be the like in course. So usually we have sessionals, so maybe some 20 to 30% goes from the sessionals and 80% comes from the end of the year examination or the end of the semester examination. So these guidelines are very rigid. These guidelines are rigid. So as a like a as an academician, we can advocate the curriculum reforms, that is possible. And in case of the private university, yes, they can also, it's easy for, for them to implement. But this is, a resistance from the regulatory bodies, it's challenging. This is one of the challenges, implementing. But it doesn't mean that, we have to, wait for the changing the, like, curriculum reforms and all. No, we can implement ourselves, as a part of our regular classes, regular teaching in the classroom. So that is also possible. But sometimes again there is a debate that if there are no marks, students don't study. Yes, that is there because students usually they study more if they have some kind of like a grading or some marks are involved. But anyway, we can enforce that. We can create that habit in the students. Without marks also they come prepared for the class and do some kind of discussion. Okay, I'm just quickly go through some of the examples of the TDS that we can implement in pharmaceutical chemistry laboratory. I just, okay, I have another 10 minutes. No problem. So, these are some of the examples. We can have any topic, just examples I'm giving here. We can have different topics. So, for example, beta-lactam antibiotics. We can talk about if they are cholinergic, SAR, NSAIDs. And based upon this, we can have some of the learning outcomes. We can focus on some of the core learning outcomes. And based upon these core learning outcomes, we can make the different, around 4 to 6 learning outcomes for the students for that particular Hebel session. So when you talk about the beta-lactam antibiotics, we can discuss about the selection of the drugs, based upon the structural modifications. Say, for example, in case of ACE inhibitors, we can ask student, to them activity related to the drug modification for the optimized therapy. So I'll take few example, just one example here, okay, related to the beta-lactam antibiotics. Yeah, so this is the TBL. Okay, we can design structure activity relationship of beta-lactam antibiotics, and we can form. This is just the example I'm giving. This is up to you, the and the faculty, what you want to have your learning outcomes. Based upon your curriculum and the syllabus. So this is my actually. Like I can say, not as the reason one, but we just a general learning outcomes. So we can ask, learning outcomes can be explain the basic principles of the basic structure of the beta-lactam antibiotic, then identify the functional group that is responsible for the antibacterial activity, discuss the instability of beta-lactam antibiotics, and analyze the ACR modification to improve the activity and the resistance. That medicinal chemistry usually they teach all this, all these aspects during our day-to-day class lecture. Okay. So based upon these learning outcomes, we can prepare the 10 to 20 MCQs. Again, it depends upon the how we implement this serial. So we can have 10 to 20 MCQs that forms the part of RADs, right? IRAT and for the TRAD. Okay, once you finish with that IRAT and the TRAD, we can give some kind of case scenario. No, case scenario. Okay. We can give some case scenario that is the team application as a part of the team application activity. So this is just the case I formulated, like a 65 years old diabetic patient is diagnosed with the UTI that is caused by the ESBL and that is produced by E. coli, and the patient was treated with amoxicillin. Okay, and but still the infection was persist, and after the susceptibility test, the resistance to the penicillins and the first generation cephalosporins was observed. And the challenge was here to overcome the resistance, the physician must select appropriate beta-lactam antibiotic. So this is the case scenario, and it should be a real life case scenario. So we can create this kind of case scenarios. Looks like very much real life scenario. Okay, so based upon this, what kind of application we can give application exercise we can give to the student? Can ask them to compare the SAR of the penicillin, cephalosporins, and carbapenems, and again, we can ask which chemical modifications can be overcome by beta-lactam resistance, and we can ask them to propose the modifications that enhance the oral stability of the penicillin. So this is the activity, or this is the application exercise we can give it for the students to do that. And finally, we can ask the we can ask the question, like based upon the ACR and the beta-lactamase resistance, which of the following drugs would be the best option? So they have to give the drug selections and the justification for that. So they have to, if they select any of these options, they have to answer that why they have selected. Okay, so that is again based upon the structural stability of the structure and all. So this is how the TBL can go for the medicinal chemistry. Okay, people can go for the medicinal chemistry. I'll give some example for the drug discovery also. This is more of like higher learning. So it can be given it for the master classes, okay, postgraduates and all. So related to the pharmacophore modeling for the antiviral drugs. So our objectives can be understand the concept of pharmacophores and then their role in drug discovery. Okay, analyze the pharmacophore features for the antiviral drugs and design new drugs. So designing new drugs is not, I know that it's not that easy task. They can do it in half an hour, but we can provide them some of the literature, and from that literature they can come out with that. So it's up to us how we can go ahead with that. I don't expect that they will design drugs in 1 hour or half an hour. Okay, but there are so many literatures. Some of the articles are there. We can give them articles. Let them analyze that. We understand what the concept of pharmacophore is there, and our features, and how they have designed the drugs, and they can explain that also. Okay, so in this case also we can use some kind of application exercise. So we can simply say that okay, there is a new that in case of COVID and all, every time the drugs were not inactive, right? So we can give them a like a new emergence of new viral strain, and how like they can design the new pharmacophoric drugs using pharmacophore modeling. So we can give the task like identify into pharmacophores, then use computational tools to generate pharmacophores. So not like using the tools in the TBL system, but the available in the literature, based upon the literature, they can analyze that, and we can propose a new drug structure. That is what we expect, and they have to present it, what pharmacophore features, and propose the drug structure. Okay, this is another case. This is mainly for the pharmaceutical analysis related to the structural registration of the drug metabolite using NMR spectroscopy. Again, we can formulate it. Okay, I'm just giving this as an example. Okay, this you have a liberty to change the objectives based upon your curriculum and all. Okay, this is just the example for understanding what how this TBL can be. Okay. So understand the principles of NMR spectroscopy, interpret NMR spectra. So just now we had one session with Prof. Biju, okay, related to the interpretation of NMR spectra, identify the chemical structure, and apply the NMR data to elucidate the structure of the drug and their metabolites. Okay, so based upon this, we can create the redundant assurance test and can give some application exercise. So here also you can use some kind of like a scenario. Okay, maybe not a real life scenario. Maybe you can create some scenario. So what in this case I prepared, like the patient urine samples contain some unknown metabolites. Okay, I want them to know what exactly the metabolite is for the particular drug. So your team must identify the metabolite using NMR spectroscopy. So we can provide them with the various like proton and carbon
Sir,
13
sorry to
NMR spectra.
interrupt, Dr.
Yes,
Bhumendra sir.
yes.
Kindly conclude in next 5 minutes.
Another
Sir.
another 2 minutes. Yeah, 2
Yes,
minutes.
thank you, sir.
Yeah, yeah, yeah. Okay. So then compare the spectra with the parent drugs and propose the structure for the drug metabolites. So that is what we can do. So this slide shows we can use the TBL cases for all the different types of spectroscopy, and we have a learning outcome. So we can have our own learning outcomes for that. Right. So in conclusion, you can say that TBL fosters the student engagement and the collaboration in the classroom. I think you will agree with me. Enhance critical thinking and problem solving activities, benefit benefit to both students and the instructors as well. Okay, and call of action, you can say we can consider implementing TBL in our classroom. It doesn't matter whether it is a part of it doesn't matter if it is a part of our curriculum or no or assessment. Okay, we can as a faculty we can think of like implementing this in our classroom. So advantage is that we don't have to teach that course. Okay, but what are the topics we cover in TBL we never teach in the class because they prepare for themselves. We don't need it. You know? And TBL, it can of course transform the pharmacy education because mostly we have uh, like a classroom teaching, that is what we are following mostly. So we can foster the critical thinking, collaborations, and the student engagement in the classroom. Okay, so this is my conclusions for the lecture. Okay, maybe we can have a poll. Uh, just if you can, fine. Otherwise, I can take some questions. So if you are interested in implementations of team-based learning activity for your course, so the faculty can, if they wish, they can involve in this poll by you just wait for a few
Yes.
seconds.
Yes.
Yeah. So they need to scan it, QR code. Very good.
Yes, we getting the response.
Yes, that's it.
So thank you very much, Dr.
Yeah.
Bhumendra
So I
sir.
just before that I just just 1 minute. Okay, I just take 1 minute.
Yes, sir. Sure, sir.
So okay, this was one of the poll I took in my university maybe last academic year. So I asked my faculty, during the presentation, whether the TBL is a teaching methodology, assessment methodology, or learning methodology. Okay, so this was the results. Majority of people they thought it's a learning, but so multiple, they can select the word. But of course, it can be a teaching methodology, it can be assessment methodology, also it can be a learning methodology. Okay, with this, I thank our President Prof. Ismail Masalka for and my Dean and VPR, Prof. Muhammad Al Thanani, and of course the organizers, okay, Dr. Rakesh, Dr. Hari, for inviting me and giving this opportunity to express my thoughts about this new technique. I'm sure it's difficult, to justify this topic in
Yes.
45 minutes. Impossible marathon task.
Yes, sir. Yes, sir.
Yeah.
Sir, but you have explained in a very poised manner steps included in team-based learning. It was extremely effective, sir. And we're really feeling inspired to implement this technique. Of course, in chat box, one delegate has posted that this is a very good approach to train pharmacists, but considering the time constraint regarding syllabus.
Exactly.
Yes, sir. But still,
No,
I think
exactly what I feel. I know it can be a part of lecture. So I don't want to teach, the antibiotics. So I can give them the material. Okay, you can motivate them to study, and then we can have the session. Possible, possible.
it is
Challenging.
possible. For some topics, at least, this has to be
Exactly,
taken up,
exactly,
sir.
exactly. Yeah. But
So,
anyway, it requires, a lot of workshops and the training for the students, training for the faculty.
yes,
Good
sir.
practice.
So thank you very much for this
You're
incredible
welcome.
session, sir. And it is
Thank
our
you very much.
pleasure to present you with a certificate for being a great resource person.
Thank you. It is well received. Thank you.
Thank you, sir. Thank you, sir. Have a great day,
Thank you.
sir.
Thank you to say.
Moving ahead to the last and most awaited session by an illustrious resource person, Professor Dr. V. Algar Sami. Professor Dr. V. Algar Sami is a distinguished academician and internationally recognized scientist in pharmacy. Ranked among the world's top 2 scientists by Stanford University, USA, he holds global subject rank of 1561 and is the top ranked scientist in Telangana in pharmacology and pharmacy. Sir has patented a novel drug molecule and new product development. Recently, he was honored as a Fellow of the Royal Society of Chemistry, London, UK, for his magnanimous contributions. Dr. V. Algar Sami earned his degrees from esteemed institutions, including PhD from the MS University of Baroda. Sir is also qualified GATE with an impressive 95.1 percentile and All India rank of 52. Sir's research is focused on synthetic medicinal chemistry, heterocyclic bioactive compounds, and phytochemicals for viral diseases. Sir has made significant contributions to the development of quinazoline-derived drugs, collaborating with global research institutions like National Cancer Institute USA, Rega Institute Belgium, and Sudbury Regional Hospital Canada, with funding support from CSIR, DST, and DSIR. With over 200 publications in national and international journals, his research has been widely cited, accumulating 4300 citations, H index of 35, and I-10 index of 84. Sir has authored several widely recognized textbooks published by Elsevier and other renowned publishers. Dr. V. Algar Sami has received multiple Best Research Paper, Best Researcher, and Best Principal awards. He serves as Director of Research and Development at MNR University and is member of Board of Management. A recipient of Young Scientist Project from DST, Sir is also co-editor of international journal Anti-Infective Agents, Bentham Science Publishers. Sir has played key roles in pharmaceutical education, serving as a member of AICTE's All India Board of Pharmaceutical Education, Board of Studies at Osmania University, and doctoral committee member and PhD guide. He has successfully mentored 10 PhD scholars. Sir, we are humbled by your presence of such a highly regarded researcher among us. I welcome you, sir, with bottom of my heart and invite you to deliver the address. Thank you.
Thank you, madam. Thank you.
Thank you, sir.
Can I share my PPT?
Yes, sir, please, sir. Sir, PPT is visible.
Full screen visible, no?
Yes, sir, it is visible, sir. Full screen.
So good afternoon, Dr. Somani, the principal, School of Pharmacy, D.Y. Patil University, Mumbai, and the organizing committee members, and all my dear pharmaceutical chemistry teachers who are joined in this platform. So really, I feel very happy to address in this August gathering. Why? Because meeting chemist always chemist feel one excitement where the chemistry starts. So I feel very happy and honored by Dr. Somani by inviting me to this address in this e-FDP. So the topic itself, I have chosen chemistry in pharmacy. The e-FDP organized on the topic of how to engage the pharmaceutical chemistry students in the classroom is typical. Why? Because now the students' interest in the chemistry is coming down. Many of the students are deviating from chemistry, and many of the faculty members are lacking knowledge of chemistry and losing the interest in chemistry. Ultimately, where the pharmacy profession goes without chemistry. So when approached by Dr. Somani, immediately I accepted because he always come up with novel ideas. I feel happy. I have given this topic of chemistry in pharmacy with the mindset. Chemistry in pharmacy, we need the chemistry in pharmacy, and we should understand the chemistry of the drugs. For that, we need the chemistry. To have the better pharmacological action, we need the chemistry. So without chemistry, the profession of pharmacy cannot be built. This is my view. So in my presentation, I would like to cover two things. One is the importance of chemistry in pharmacy. Another thing, how to attract the students into the profession of pharmacy in pharmaceutical chemistry, so that our chemistry background or our chemistry fundamentals will be much more than any other people's in the healthcare team of healthcare team. So let me start the importance of pharmaceutical chemistry. No one can deny chemistry is the heart of discipline of pharmacy. No one can deny chemistry is the heart of discipline of pharmacy. Every living organism is a test tube, and we discover the medicines by various chemical reactions in the laboratory, and sometimes we obtain from plants. Plants itself carry these chemical reactions. Pharmaceutical chemistry encompasses all the chemistry related subjects, like which includes medicinal chemistry, pharmaceutical phytochemistry, analytical chemistry, and all the chemical aspects of the drug molecules. Many of the students now asking, is chemistry important for pharmacy? These questions arise not only when I visited some of the colleges. I heard through my professors or through my colleagues this question, is chemistry important for pharmacy? The reason why this question arising from the students' mindset is because of the difficulties that they are facing during the learning of subjects like organic chemistry or medicinal chemistry. This is the reason this question arising. No one can deny chemistry, how much it is important in the profession of pharmacy. Not only in pharmacy, nowadays you can see the chemistry everywhere. Without chemistry, the world cannot exist. That is the fact. If you see any of the top plays or any of the top success, they have the chemistry background or they have the chemistry wise they play. That's why they are succeeding. Why we will talk all these things? If you see any of the dance program, in the finals somebody lose that winning chance. They say you are in your choreography. We feel little chemistry the missing in your dance. That's why like that people are talking about the chemistry. So chemistry is that extent it is penetrating. But coming to the profession of pharmacy, the chemistry is going away day by day. This is what my feeling I am observing. So what are the role chemistry is playing in the pharmacy? So if you all know these things, definitely we can be come up with a confident mind. Without chemistry, pharmacy cannot exist. For designing any new drug molecules and development into this, we need the chemistry. And for testing the drug quality and the how to perform its assay, we need the chemical nature of the drug molecule. For understanding the mode of action of the drug molecule, we need the chemical nature of the drug molecule. For formulation into a suitable dosage forms, we need the chemistry of the drug molecule. Pharmacological action and the toxicological action is based on the drug molecule chemical structure, how it is binding with the any of the receptor, and how it is eliciting is the pharmacological action. It also chemistry interconnects all other discipline with the pharmacy, and for acting any of the biological nature in the biological nature, the chemistry plays an important role. Without the chemical interaction, the drug cannot act in the animals. To develop any novel therapies like gene therapy, all there also we need the chemistry of the drug molecule or chemistry of the nucleic acids. And for having any regulatory affairs and the pharmaceuticals, we need the chemistry. And to have the finally patient compliance with the have the suitable drug formulation, we need the chemistry of the drug molecule. So I can conclude that it is the foundation. The pharmaceutical chemistry is the foundation on which the entire pharmaceutical field is built. This nobody can deny. So my dear young or my dear experienced, my dear pharma students and teachers, kindly take this note. Without pharmaceutical chemistry, pharmacy profession is not there. And with this mindset and in the confident mode, you go ahead. So definitely you can fetch the highest positions in the healthcare team. So to learn this chemistry in pharmacy, we need to know some of the tips and tricks so that students cannot deny or deviate from the subject. So when we approached for this type of FDP, I always try to give on my experience how I make them to study in the classrooms. I give them many of the success stories also I got. So that's why I am taking forward these stories to many wherever possible. So this is one such a platform. I am explaining my experience among the students where I could succeed with in the classroom. Because of my success in the classroom, I am able to write these many books. I have authored almost 7 books and 3 co-authored books. Total 10 books I have authored in the profession of pharmacy. All the books are well appreciated by the students and faculty members all over India. That is because of the simplified nature of the books that we have given. So here I would like to sum up the simplified techniques or methods how we can make our organic chemistry and all other chemistry subjects easy for the students so that they will come forward and they will start loving the chemistry. Once they start loving the chemistry, their attachment cannot leave from the profession of pharmacy. So my dear teachers, those who are teaching in the first year, B pharmacy or pharma D, if you start developing this type of small tricks and tips, so they may start loving chemistry, because everyone will agree with me. The students of pharmacy, they are not determined from the 10th class or 12th class, I have to study pharmacy. They are landed in pharmacy after they are not getting the MBBS, BDS, homeopathy, so Ayurveda, and so many other courses like engineering, MPC stream. If you take, if they are not getting in any engineering good college, then they are coming to pharmacy. So the students of pharmacy, they are not directly taking or determined to take into pharmacy because they didn't get any of the other courses. They are coming into pharmacy. So our teachers' duty is we have to start educating from the beginning, from the first year. If we start educating, then they will start understanding the importance of the chemistry as well as the pharmacy profession. Then they can do well. So in the initial period of my career, after doing my M Pharmacy from Gujarat University, PhD from MS University, B.Pharm from Madurai Medical College, all the premier institutions, when I started career in a rural place for the teaching, so when I started explaining with all my reaction mechanisms during the synthesis of organic compounds, with the only in English. So they started hating the subjects. They started hating the subjects because where all the nucleophilic reaction, electrophilic reaction, all when we started taking, they started hating. So I understood. So whatever we studied cannot be imbibed on the student. So we should adapt some other methods, or we should have some different simplified methods in order to reach the students. So I started myself to plan some of the things that will make the interest of the students towards the pharmaceutical chemistry. So here are some of the subjects when I was teaching, how I could attract the students towards my subjects, and I could get. And interestingly, initially maybe 1 month or 2 months they hated me. After that, whatever they I have started teaching, they started loving me, and as a result of which, many of my initial college students, they started career for the pharmacy, pharmaceutical chemistry, and many have done MS and with the chemistry background, and they are doing wonders. Even now in our present college, we have the pharmacy 100% admission. The reason behind this, we try to teach the chemistry in a simplified way. So I hope if all the teachers, if they take these small tips and tricks, so I think the success the chemistry in pharmacy will penetrate, and we'll get the pharma students will excel. Another important point I would like to mention that in healthcare team, everyone have the specialized skills. Like doctors, if you take, they have the identification, they diagnose the disease and prescribe the medicines. And in the nursing profession, they take care of the patients, and really has been taken by the nursing professionals. And physiotherapists, they play a role when they are without a medicine or with the minimum medicine, how to do exercise and how to rectify our ailment, like that they are doing. And coming to the profession of pharmacy, what skills we have? Our skill is only drugs. These drugs and pharmacology, everyone in the healthcare team are studied, like doctors, nurses, physiotherapists, all are studying the pharmacology. We are also studying pharmacology, but we study medicinal chemistry that other profession of the healthcare team are not studying. That is the advantage. So that means chemistry is the our topmost point. By using this, we should lead, or we should play a significant role in the healthcare team. If we don't have chemistry, we are nowhere in the healthcare team. So, my dear teachers, so we should take this point, and all our chemistry knowledge in the definitely will play a crucial role, and we can explain like each drug why it is more active, why it is less active, why it is easily eliminated, why it is having toxicity. Based on the drug molecule chemical structures, we are able to answer why this metabolite is can be synthesized as a new drug. That's how many of the drugs have been. Hydroxyzine metabolite is the cetirizine. We found and from the propranolol, it is recommended for the beta 1 blocker. Later on, it was found to have the psychological disturbance because of the polar nature. It crosses the blood-brain barrier. So like that, we can talk n number of things, how it is affecting the therapy, how it is affecting the drug molecule. So my dear pharmaceutical chemistry teachers, you are the king, that you can address all the issues arising out of the chemistry. So here are some of the tips I would like to mention, how you can attract the students into the subject. Coming to the subject, first in the first year they study pharmaceutical inorganic chemistry. So the students, when they study pharmaceutical inorganic chemistry, like preparation of sodium chloride, that they have already studied in intermediate. Sodium hydroxide plus HCl gives sodium chloride, that they know. So like that, many of the basic chemical reactions they know. But the important difficult things that they face is the assay. Assay of the inorganic compounds only they feel difficult. So here, if we have some attractive way or some of the tips how to remember, so they may feel okay, comfortable, or they may come forward and to do excel in the inorganic chemistry also. One example I would like to say, compounds can be assayed by two ways. One is direct titration, another one is back titration. So this is why many of the students get a doubt what is back titration. What is the difference between direct titration and back titration? As you know, direct titration means directly titrating the reagent with the titrant and getting endpoint with the support of any indicator. Coming to the back titration, we add some of the substance excess to the sample. We add the known excess standard reagent. So in this ammonium chloride assay, we add known excess standard silver nitrate and the excess unreacted silver nitrate is back titrated with ammonium thiocyanate. Here I have mentioned known excess standard means this is the keyword in the back titration, and excess unreacted reagent is back determined by titrating against ammonium thiocyanate. This is the again another key thing. So these two key things are important in the back titration. Just how to make the student to remember. I have given this keyword known excess standard. So we can tell a story like this in the class. Where for welcoming any people, each country or each place has its own way of welcoming. Like in India, we say namaskaram to say welcome, and in foreign countries like you say US and UK, they say hug, or they say shaken, or they say kiss. So here if you say in Europe, that is the EUR, I have mentioned as Europe. To remember Europe, I have given. They kiss, they say kiss to welcome. Instead of KES, you put EI. So they will remember now. So now the student will not forget the word KES, and the student will not forget Europe. So in Europe, they welcome by kiss. So you remember, use this sentence. So what happened? Student will always remember back titration means KES and EUR. These are the two keywords we should remember. So in this assay, we are using the known excess standard silver nitrate and the assay of ammonium chloride, and the excess unreacted silver nitrate is back titrated with ammonium thiocyanate. So this way they will remember, and followed by indicators, all these things we can say. This is one way that how to make the students to attract and remember thing. And this is another simple thing, iodimetry and iodometry. Many of the students used to get confused. Iodimetry, by the pronunciation itself, says iod. Iod means here it is. We say here. Iodometry means it is somewhere we are calling. So we can easily say that. So we say, insist the student, iod means iodine available here. That is, directly iodine is taken and titrated with sodium thiosulfate, and this is the direct titration. Whereas another method is iodometry. Iodometry is used for some other compounds like chlorinated lime, copper sulfate and all. So where iodine is liberated from some other potassium iodide, and this potassium iodide is from potassium iodide, how we get by oxidation, by reaction with chlorine. This chlorine, how it comes? Because of the reaction between hypochlorous acid and hydrogen chloride. This in turn is liberated from chlorinated lime by reaction with the acetic acid. So this potassium iodine is coming from the somewhere else, that is in the outside source or somewhere we are getting. So it is called as iodometry. That is calling iodine. So when we call iodo, come here, like that we say. So you start pronouncing this way, so the students will not forget. Iodometry means it is a indirectly we are getting, or we are calling iodine from some potassium iodide. So this is how we can distinguish iodometry and iodimetry, so the students will not get confused at any point of time. Next, I would like to say permanganometry. It is also another important method in the inorganic chemistry, where many of the compounds are assayed, like hydrogen peroxide, copper, oxalic acid can be assayed by this method. In this assay, if you see, the sample is diluted with hydrochloric acid, and followed by it is titrated again potassium permanganate using self-indicator. So in this reaction, what happens in this assay? Potassium permanganate reacts with sulfuric acid and forms the potassium sulfate, manganese sulfate, and nascent oxygen. This nascent oxygen only oxidizes hydrogen peroxide into water and oxygen. So this first reaction is common for all the permanganometry. That is 2KMnO4 plus 3H2SO4 that gives K2SO4, 2MnSO4, 3H2O, 5O. This reaction, if a student remember, at least 4-5 assays can be remembered easily. So that's why I given 2-3 gives 1-2-3-5. That is 2KMnO4 plus 3H2SO4 that gives 1K2SO4, 2MnSO4, 3H2O plus 5O. So this is how these numbers can be useful to remember. Here again you may get the doubt how to say KMnO4. Remember how to say KMnO4 first or H2SO4. We all know in any of the things hero only comes first. Like in the movie, whenever we said Amitabh Bachchan is the hero or Shah Rukh Khan is the hero or some Ajit is the hero, only hero name comes first. Permanganometry, hero is the first, potassium permanganate. So this is how we can remember, and with this total reaction can be written very easily. Coming to the second reaction, hydrogen peroxide oxidizing by nascent oxygen. This total two reaction we can add and we can write like this, so that this reaction can be easily written. So similarly with this reaction, they can also be applied to the oxalic acid. So first reaction common for say for all the reactions of potassium permanganometry. Second reaction only changing. So again only change the second reaction and just add it, submit these things and write the final reaction. So when we do write this type of small tips, students will start understanding and they keep it in mind. Because as I told you, we are not getting the students who have the 100% basics like those who are preparing for JEE or the NEET. We are getting the students are very average. In India, almost 90% of the colleges are of the private institutions. In order to run the institutions and make the pharmacy student success, we have to adopt this type of techniques that will surely make the students life at the college and in the classroom happy. We can take a next example coming to the organic chemistry, that is in the first year BPharm as well as in Pharma D. We can say SN1 reaction, it's the unimolecular reaction. Many used to have how there are two steps reaction takes place and there are two molecules are involved in the reaction. But how they say unimolecular reaction, why they are telling. And next question, in the first step goes slowly and second step cation formation it takes slowly and the attack of nucleophile takes fast. But we say slow going step is the rate determining step. So in the SN1 reaction takes place by two steps. One is the formation of carbocation. Second is the attack on the carbocation by nucleophile. Among these two, the formation of carbocation is the slow going step. So that is rate determining step. Whereas fast going is not the rate determining. The students sometimes get confused. In order to make the students to remember, we can tell a story like this. So assume that a couple is staying in the staff quarters and they wish to go for the movie nearby place having a small kid. So the kid wants to walk. So couple as and the small kid, all three are walking. So as we know, the couple go fast because the show will start. So we have to reach the cinema theater early, like that they think. But the kid don't know all these things. He started enjoying the slow walking. So kid is going slowly, whereas the couple wants to go fast. But the slow going kid only determining the speed of the parents. So if we say this story, they will never forget slow going step is the rate determining step in the when there is SN1 reaction. So these are all some another in the organic chemistry we say. So in order to remember some of the organic compounds, we can use some of the phrases, techniques like monocarboxylic acid. We can easily remember based on the name. Methane, methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, like that. Based on the number and in the Latin 1, 2, 3, we can remember. But coming to the dicarboxylic acid, it cannot be remembered like that. So we need some help or we need some way to remember. So we can use these things. Like if you see the first letter of the dicarboxylic acid, I have underlined. If you correlate, we can get the word called Ohms Gupsas. Ohms, OMS. Everybody in India knows Om, the word, and Gapsas. Also, everybody knows. So, Ohms, Gapsas, if you say, they can easily remember the dicarboxylic acid, oxalic acid, malonic acid, succinic acid, butyric acid, adipic acid, like that, they can easily remember at a stage, and they will never forget in their life. That is the important thing we can mean when we go this type of tips and tricks. Another example I would like to say in the organic chemistry. So, as we all know, alkyl halide, when we react with the aqueous alkali, it gives alcohol. That is RX, X is replaced by OH, substitution reaction. So, alcohol, that is sodium hydroxide, when we dissolve in the water, it gives a substitution reaction. Whereas sodium hydroxide, when we dissolve in the alcohol, that is alcoholic potash, it will give the elimination reaction. So we say many of the students used to confuse with which is a substitution reaction, which is elimination reaction. This also can be framed with the story like if suppose the students are going in a college tour, if somebody comes with the alcohol bottle, we always throw them out. We send them out. That is kick off. That is called as elimination. Suppose if someone come with the aqua in a water bottle, we always invite them and make them to sit here. So this is another way we can say alcohol means elimination. Alcoholic potash means elimination reaction. Aqueous potassium hydroxide means substitution reaction. So we can remember well these reaction also. So without any confusion. Similarly, this that is essential amino acids can be remembered by this way, that is mat will fly like this. So methionine, arginine, tryptophan, threonine, and valine, isoleucine, leucine, phenylalanine, histidine, and lysine. So we can remember like this. So like this, like organic chemistry, inorganic chemistry, and in medicinal chemistry also we can play wonderful roles by adapting the methods called how to remember the chemical structure one way based on the chemical nature, like what we say, you say procainamide. Procainamide, if you say it is a local anesthetic, it is having the amide moiety. So based on the chemistry as well as the drug name correlate, so they will remember. Coming to important difficult part of the medicinal chemistry, many of the students feel is called synthesis of the drug molecule. So synthesis, we can say retrosynthesis, if we apply what you call synthon approach. So retrosynthesis or synthon approach, if you teach to student, so definitely they will remember how to break a molecule. So like if you take aspirin, aspirin can be synthesized from salicylic acid. How to synthesize salicylic acid? By salicylic acid, we can go back by from the phenol. From phenol, if you do the Kolb's condensation, we'll get salicylic acid. COO we are adding. So if you say this, students will not forget the chemical structure of the chemical structure, as well as they will be able to synthesize the drugs in a simplified way. So if you do adopt these type of techniques, I think our students will come forward and they will show interest in the chemistry, and they will all feel happy with the profession of pharmacy. That's how we can play a significant role in the healthcare team. I think with this, I would like to conclude my presentation, because already it's 1:40, maybe lunch break. So with this view of the my experience, I thank the organizers for giving me this opportunity. And if everything okay, if the way how I presented, if you like, as we the present day we say, like, share, and with all. If you don't like, please excuse me for making this chemistry in a like a very colloquial way. I feel happy to do the chemistry, pharmaceutical chemistry this way. Because of this, I could get my students as a friends. Earlier, they were treating me like an enemy. Now they are treating me like a friend. So I am happy with what I am doing. I hope you also will agree with me. So thank you. Thank you, Ananda.
Absolutely, sir. Like your name of your topic itself is very hard hitting, chemistry in pharmacy. You rightly said that without chemistry, pharmacy is nothing, and chemistry is everywhere. The way you have explained the tricks and tips, it was so very relatable, because those topics we teach, and we could really make out that using such tricks, students can be really involved into it, and memorizing part will become really very easy. Thank you so much, sir. As a token of gratitude, I would like to present the certificate. Meanwhile, any questions, please put up.
Maybe everybody must be having a lunch break now.
Sir, please accept the certificate. It is our pleasure to present you with this certificate, being resource person for the event. Thank you, sir. Thus we come to concluding part of the 2 days e-FDP event, wherein we got opportunity to listen to some of the most illustrious academicians and researchers. So now I request event coordinator Dr. Harish to summarize the event and propose vote of thanks. Thank you all for the kind cooperation. Dr. Harish, please.
Thank you, ma'am. Thank you, Professor Alagar Sami sir, for accepting our invitation and for the wonderful talk. I'm very sure that your talk will get all the likes and subscribes and hearts. Thank you so much, sir.
Thank you,
Okay,
sir. Thank you, one and all.
So before going on to the Thanksgiving session and the concluding session, I'll just like to summarize and give some instructions about the quiz that is going to pursue now. So we had we'll have the quiz and the feedback, which will be shared in some time on the WhatsApp group for the delegates. And those who get more than 60% marks, they'll be eligible for getting the e-certificates. And the quiz link as well as the feedback link will open at once, and that will be somewhere around 2 p.m. It will be kept open up to around 5:30 p.m. Having said that, let me talk about the 2 days of the e-FDP that we have been through. We received around 362 registrations from all over India. For day one, we had around 681 views. So that is more than 600 views on YouTube channel. And for day two, till some time back, we had around more than 300 views for the videos that we have been posting. So thank you so much to all the participants, all the delegates for for all the views, for listening to all the talks so carefully. We are grateful to our patrons, Dr. Vijay Patil sir, and who is the chancellor and the president of DY Patil University, and Dr. Shivani Patil ma'am. She is the pro chancellor and she is the vice president of our DY Patil deemed to be university. Big thanks to our chief guest, Professor Jaikar, for the inauguration and for the great start to this e-FDP with his talk. We are grateful to our principal, the APTI MS President, that is Maharashtra State President, as well as the convener of this e-FDP, Professor Dr. Rakesh Somani. I at an individual level, I look at him as a visionary leader and a very good teacher. So it was his idea and vision to do something for the teachers of pharmaceutical chemistry that we came up with this e-FDP. Needless to say that he is himself a medicinal chemist and a very good teacher, teaching different chemistry subjects different chemistry subjects to pharmacy students. And that was the reason why he had this vision, and we all were pursuing his vision of doing this e-FDP. I'm also thankful to the speakers for their enlightening talks and for guiding us all with their teaching experiences. Grateful to all the participants, gratitude to all the participating faculty delegates, because without you all and without your interest in teaching chemistry in pharmacy, this e-FDP would not have been successful. I wish to heartily thank all my departmental colleagues. Without each one of them, this e-FDP would not have been possible. So at this point in time, I'll take the names in the order of their duties. Okay. So Mr. Sahil Devnani, he was responsible for registration and for the QR codes for registration as well as the WhatsApp group that we all see in the flyer. Then we have Mrs. Tanishka Thakre. She was responsible for the flyer, and indeed she has done a wonderful work with her with the making of the flyer, as well as the PPTs that we are seeing in between, the speaker slides, the certificate slides that were done under the guidance of Mrs. Tanishka Thakre. Then Dr. Praveen Naik, he was responsible for the technical aspects of this e-FDP, the Zoom platform, the YouTube platform, and all. Dr. Prateep Chaskar, he was responsible for the formats of the certificates for the speakers, delegates, and all my departmental members. He was also responsible for the feedback questions that you all will be receiving in some time. Dr. Suraj Mani, I'm thankful to him for the certificates. He'll be responsible for the certificates of the delegates, and he's also responsible for the quiz questions that you all will find in the WhatsApp group in some time. And from the faculty side, last but not the least, Dr. Monita Gide ma'am for her fantastic anchoring and comparing throughout this 2 days event. I will also like to thank Mr. Tejas Sapkar from non-teaching IT department who has been of great help throughout this e-FDP. We hope that all the faculty members have learned a lot over these 2 days from all the eminent speakers that we had, and we would all apply all of these learnings with our students. In my welcome speech, I had mentioned about the 5 E's, which were we have to be, we teachers are supposed to be ethical, enthusiastic, energetic, equitable, and excellent while at the task of teaching and shaping our future generations. At this point in time, let me mention, when Professor Alagar Swami was speaking, we were listening to his talk, and on the background, we were seeing all of his awards kept in that rack. And also, there was this photo of Mahatma Gandhi ji behind him. So let me quote Mohandas Karamchand Gandhiji. He had said that we have to be the change we want to see in this world. Therefore, we as teachers, we have to lead by examples, by exhibiting all of these 5 E characteristics. Because even if no one else understands, our students do observe us and they do understand. Okay, we have to all remember this. This is very, very important. They do observe and they do understand. And then obviously, when we want our country to be on the forefront of drug discovery, then definitely we have to be the change that we want to see in the world. Okay. Now, another great person that was born on the same day as Mohandas Karamchand Gandhiji was Lal Bahadur Shastriji, whom I admire a lot as a visionary leader. He was a simpleton, our prime minister, right? Second prime minister of our country. And he always stressed upon simplicity in his life. So, taking, acknowledging his life, let us make our chemistry very, very simple so that our students find it easy to understand. Okay, as Alagar Swami sir and all the eminent speakers were pointing out, we have to simplify, we have to lead the way, we have to be good at our basics. Then we can think of, improving the basics of our students. Okay, then last, I would also like to quote Sir APJ Abdul Kalam. He had said that if I teach a fish to fly, I would waste its entire life trying to teach it to fly. Therefore, I would request all the faculty members present here that we have to, not think as to, yeah, how do we teach this fish to fly? Okay, we have to identify who are the fishes, we have to identify who are the birds, and then we have to teach them accordingly, right? So we have to teach the birds to fly, and we have to teach the fishes to swim. And only then, when we want our country to progress on the drug discovery front, okay, only then we'll be able to make our own contributions as teachers in shaping the lives of our kids, our students, in a way that they, address the future of our country and bring our country on the world's drug discovery map. Okay, recently we had this drug nafithromycin, which was discovered in our country, right? Why not many other drugs? Okay, and who can do that? Our students can do it, we can do it, right? And if we have to do it, the best way to do it is inspire the students, motivate the students, right? So that's what we have to do. Okay, so as rightly mentioned by many of the eminent speakers, pharmaceutical chemistry is the starting point of pharma research. Because we are concerned with drug design and discovery, we have to be at the forefront. We members of the Department of Pharmaceutical Chemistry, we members of the Pharmaceutical Chemistry Fraternity, Medicinal Chemistry Fraternity, we have to be at the forefront of drug discovery. A teacher is a teacher of all professions, it is said. And so, please remember, while everyone nowadays talks about good researchers, excellence in research, we academicians, we the teachers have to first believe that we have to be good at teaching. First, we have to be good at teaching so that we can inspire and motivate our kids, our students to do good chemistry, do good drug discovery, and do something good for our nation. With that, I'd like to conclude. Thank you so much to all the teachers who are present here and making this FDP successful. Thank you so much. Over to you, ma'am.
Thank you, one and all. Thank you, Dr. Harish, for that wonderful vote of thanks and summary of the event. Sir, any instructions about the quiz and feedback? Those have been shared.
Yeah. So, as was mentioned just before the Thanksgiving talk, we'll have the quiz and the feedback, all of it sent via a Google form. Say, suppose in the next 10 to 15 minutes via the WhatsApp group. And I'll request all the faculty members to fill it up by 5:30 p.m. today. Okay, so we'll close the link for the quiz at 5:30 p.m. today. I understand that we all understand, all the faculty members of my department. We all understand that, all the teachers, some of us may be busy with our lectures, maybe our practicals. So that's the reason why we have kept the quiz for an extended period of time. So say suppose if someone missed out on some of the lecture from our eminent speakers, then you can just watch it on the YouTube because it will stay over there, okay? And then you can attempt the quiz also. Okay, so we'll be keeping it open up to 5:30. Please do attempt all the quiz as well as give the feedback by 5:30 p.m. today. Thank you so much. And then I think we can dissolve the e-FDP for the day. Acha, just for the information of all the eminent speakers, I think Alagar Swami, is he there? No, sir. Oh, sir. Professor Alagar Swami, sir. Uh, Professor Rakesh Somani, sir, is traveling as of now, and his phone has gone low on battery,
No
so
problem, sir.
he could not attend the e-FDP. I mean, especially your talk. He was very
No
enthusiastic
problem.
about coming for your talk. So I'm just conveying his regards to you all, you, sir, and also to all the faculty members who are a part of this e-FDP. Thank you so much. Thank you so much, sir.
Thank you very much. Well done, sir. All of you done well.
Thanks.
Thank you, sir.
Thank you.
Thank you, one and all, for the kind cooperation. Let's look forward to another such wonderful opportunity to hear from such eminent speakers. Thank you. I will conclude and dissolve the meeting. Thanks all. Have a great day.
Thank you, ma'am. Thank you, everyone.